Earth is very flat.
What's going on, everyone? It is Monday, June 28th, 2021. This is Brandon, host of Brandon's Show. How are you doing? How was your weekend? Hope everybody had a good one. I hear a lot of football talk, or as soccer talk, as we call it. And I just want you to know that I couldn't care less. I couldn't care less what's going on with football. I have no idea what's going on. I tried. I really tried to like it, and I just couldn't get into it. But glad you guys enjoy it. Logan's Run, PJ Cruikshank, Greg T, Gadget Inspector, Cleary. Let's see who else we got. Page 42, They, White's Word, Bill G, and Globe Thrusters. What's going on, guys? Paul, you were first. Just to confirm, sound is good. And after I insulted everyone's national pastime, see what we got on the agenda tonight. I don't know. I'm actually not feeling very good right now for some reason, but the show must go on. And looks like we've got quite the crowd queuing up in the Discord. So let's get to it. What's going on, guys?
What's up, Brandon?
Hey.
What's up, Brandon?
Hey.
It's 100 degrees. I'm fucking dying.
Yeah, me too, man.
It is. It is fucking hot here too.
It's called global warming.
Right.
Yeah.
It really is. It really is.
Yeah, right. Yeah, it's called summer.
Yeah, Brenda. We
Don't you mean climate change, Brender?
Yeah, because wasn't it snowing just a few months ago in Texas?
It was first it was global cooling, then it was global warming. It's climate change now. Get it right.
Yeah, none of that is actually true.
Huh?
None of
Agreed.
that.
None of that is actually true.
I couldn't agree with you more, Brenda.
Yeah, that's not what I said. I didn't say that global warming isn't true. I said that your misconceptions of it are false.
Nah, truth always wants to get out, Brenda. Just escaped a little there. That's all.
The truth is that the Earth is warming because of CO2.
Okay.
Brandon, do you have a second, mate?
Yeah.
I hate to be rude, guys. The intro's ready, and I kind of need just like 5 minutes of your time.
Yes.
If possible.
Yes.
Just to get the OBS bit set up. It won't. I want to quickly share it with you, if possible, just to see I'm on the right track. But
you want to do it right after this show or in the morning?
Is
that what you're thinking?
Ideally, if you've got 5, I'm really busy tomorrow. England's playing Germany, mate. So I'm going to be busy for the next few days. But if you got a second, I can show it here. I mean,
oh, you want to do it right now?
Wish. Well, just to show it you, see if you're happy with it.
Sure, we're live, but
It's up to you.
Yeah. Yeah, if you want to. Sure, let's take a look at the new intro.
Okay, then. You have to bear with me.
Okay.
I wasn't prepared to do it just yet, so.
Anyway, we were about to close out that debate on global warming, but this is definitely more important.
Okay, how do I do it then? You'll have to help me because I'm a bit of a virgin in Discord. Okay. So what do I do? Screen share.
Yep.
Okay, screen.
Pick the right screen.
Yeah, audio. I'm getting it. It's fairly straightforward, isn't it?
Yeah.
Okay, so if you guys got a bit of a fuzzy screen.
Let me see what we got here. Yep, fuzzy screen. Is there sound? Obviously. Let me make sure the sound is on for the audience.
Yeah. I've just paused it. It just kicked in.
Okay.
So I'd like to say that the track is Brandon's choice.
Oh, we can always change the
taking me
track,
down.
guys. Okay, let's just
Yeah.
keep that in
Halfway
mind.
down, he changed the track. Can you believe it? It was
Well,
like,
I didn't want to be a pain in the ass. I just, I heard
But
the
you
song. And I was
were.
like, this might be cool, and I don't even know if I like it anymore, to be honest with you. But we'll see. Let's take a look at it. Yeah.
Right. Okay, I'll mute up and then I'll press play. Give me a shout if you can't.
All right. World premiere. Finally, we're gonna have a new intro. Thanks to Adam. Hey, Adam. Oh, it's interesting so far.
No, baby, don't play with me. Sugar, don't play. No, honey, don't play with me. Baby, don't play.
Can you guys hear that audio?
YouTube.
Adam, the sound's not coming through that good, but
Yeah, you can actually hear it in the YouTube, Brandon.
huh? Is it not coming through
It
YouTube?
sounds good. Yeah, it sounds good in the YouTube.
Oh, does it? Oh shit, maybe it's just me. Sorry, guys. Well, that was pretty cool. The sound wasn't coming through that good for me, but that was definitely looked interesting, Adam.
If you open up Skype, I'll send it you in there. And then you
Yeah,
can probably hear it
unfortunately,
better
I'm
then.
locked out of my Skype right now. But I should be in there today, and I will send you. I'll ping you once I'm in there. That's awesome, man.
send
Thank you
files
very
in.
much.
I accept. Is that with what you were after?
Hey, that works. And you know what? It's a lot better than what we had. Well, I couldn't hear it that well. It wasn't coming through that good, so I don't know how it sounds. But yeah, I'm very happy to have a new intro. Thank you very much.
No worries, pal. When you've got 5 minutes, I've done your OBS screens as well to match it up and the text chat. So please check Skype. There's a couple of requests just to finish it off, and then I'll pestering you.
Yep, will do. Thanks, Adam.
No worries, guys.
All right, guys. Where are we at? What's going on? What happened over the weekend? Anybody got any big news? No?
Hey, can you guys hear me?
Yeah, now we can.
Yeah, okay. I'm in the van right now driving. I'll be home pretty quick here. But on Saturday and Sunday, I decided to pop into the channel and just kind of sit and see if some folks came by. And both days, we got up to, I think, around 15 to 20 people and getting some conversations going and stuff, and I appreciated that. That was pretty nice. There is something that I do want to bring up from one or two of those conversations. Once I get home, I kind of want to talk to you guys about it, and it has to do with our vision and the arguments that are being made there about how we're seeing things and whatnot.
Why is that difficult?
I didn't say it was difficult. I just said I wanted to talk about some stuff or whatever.
But why is it difficult for you to understand how vision works?
I didn't say it was difficult. You're adding words that weren't in my sentences.
Why do you immediately
don't
frame
understand.
something like that, Brenda? Why do you immediately go
Because-
there? It's so
Why does it
transparent.
sound-
It's so fucking
Because-
transparent.
Because flat earthers do not understand how perspective works.
Oh, shut the fuck up.
When you say understand, it sounds like forcibly accept.
We don't understand. I get so sick of hearing that shit. How do you know that it's not you that doesn't understand?
Because science determines what facts are.
Who's science? Where's the book of science? Where's the king of science? Where do we find this all-knowing, all-powerful science?
The king of science is reality. Reality determines what is true.
Now you're just not making any fucking sense whatsoever. You wouldn't know science if it bit you in the ass. You've bought so far into that fucking bullshit, it's not even funny.
I
You were in
understand
here a
your
week or two
position.
ago defending fucking time travel and shit shrinking because it goes too fast.
Yes.
You
yes.
probably think it's raining diamonds on fucking Jupiter.
The reality of space-time and relativity, these are true, and they've been demonstrated and shown to be correct.
If you think that's reality, then we have a completely different definition of reality.
I suspect so.
Yeah. So stop changing the meaning of fucking words, because reality and that bullshit Einstein came up with are two completely different concepts.
Well, you're free to believe that, but you're just wrong.
It's not about belief. It's just a fucking fact. It's obvious to anybody who looks at it. Unless they want to bullshit themselves and buy into this whole, we're going to go fucking live on Mars and all that bullshit that's been sold to us. Unless you want to buy into that shit.
And also, unless they're getting paid, money is a real good incentive to believe something.
So my incentive to believe something is whether or not it's true.
Impossible.
But I don't know if you want to revisit those things, and maybe Brandon has a topic in mind, and I'm very comfortable sticking to whatever topic Brandon has for today.
No, it's an open panel. I'm up for whatever anybody wants to talk about. What do you want to tell us about reality, Brenda, that you think we don't understand?
I'm almost there.
The nature of science is that it is a method for determining what is true about reality. Right? So people have ideas.
Science does prove things.
Is it a method to determine reality or to interpret reality?
Because facts and truth are pretty equivalent to proven. But you guys all say it doesn't prove shit, so I don't know what the fuck you're talking about.
Well, when people say that science doesn't prove things, what they mean is that science doesn't give you certainty. It, like 2 + 2 is 4. That is something that can be proved.
Like a fact.
No, 2 + 2 = 4.
Fact, truth, non-subjective, everything you were just rattling off.
Not even open to interpretation, 2 + 2, right?
Yep.
Correct.
Nonsensical.
You're putting that in the same category as time dilation there, Brenda?
No, that's the whole point.
What is the whole point?
Science doesn't prove things the way mathematics does. Mathematics proves things. Science simply demonstrates what is the most likely to be the case.
You just told us it was a tool for determining reality.
Yes.
Don't you have to establish facts in order to know what reality is?
Yeah, can we live within a math equation?
I hear Brenda right here. I mean, y'all may not think it's the most solid, but it's at least consistent with the terminology.
Wait, Don, what do you agree with her on? What is it you hear her on?
She's making the distinction between the two versions of the proof. Now, I just appreciate that. I hear that at least.
Oh, I get you on there, but she just got done telling us that science is a tool for determining reality, and that science is reality. And now she's going to say, well, it doesn't prove things. Mathematics proves things. So where does that leave
Correct.
science?
Correct. Science makes demonstrations of likelihood, what is most likely to be the case.
I don't remember.
Anybody got a
I don't
definition
remember
for
being
most
told
likely?
that. Does anybody else remember getting that definition of science somewhere along the way?
So there's
They have such a fucked up version of science. It's not even funny. Like, I wouldn't go down this rabbit hole. With
And
this
every time you
stupid-
press them on it, every time you press it on it, it gets more ambiguous. Like, oh, you're most likely, maybe, you know, our nearest calculation. It's just every time you press them and ask them, it gets less and less sure of what they're talking about.
So science gives you probability, likelihood. Mathematics is deductive. Science is inductive.
No, science gives you the cause of the effect. And you can be sure if you're not doing pseudoscience. Hold on, Brenda. If you're not doing pseudoscience, you can be sure that you will have the cause to the effect when you're done doing actual science and not your pseudoscience that you guys love.
Yeah, that's the opposite. Pseudoscience pretends to be deductive. Science is inductive. It gives you, like, say, your percentages, like, oh, this is like 75% true, 90% true. Yeah, that is how it works.
That's not how it works. No.
Well, you not knowing something.
It's definitely not how it
works.
works. Brenda, did you just say science was inductive?
Yes.
Why would you say that? Could you just explain?
Because it's true.
the reasoning behind it?
I'd say it because it's true.
Isn't really an explanation, is it? That's a
Because, yeah,
belief.
that's what the philosophy of science says. Science is an inductive method for determining what is the case, what the facts are, what the likely causes are.
So now science determines the facts. I thought it was math just 5 minutes ago.
No, math determines what is absolutely deductively true.
Facts.
Does it deduce the truth or induce the truth?
What?
You know you're going to be on the next numpty clip, right?
Don't care.
Does it deduce the truth or induce?
It is an induction is an inference to the best explanation. That's what inductive means.
I didn't ask. That's not what inductive means. But,
yeah, it is.
And that's not what I asked you either. I said, does science induce or deduce?
Science is an inference to the most likely explanation.
Now we've gotten to the point where I feel like this is the mental equivalent of trying to eat a piece of wet toast. I have no fucking clue what any of your definitions mean because they're so wish-washy.
Oh, I could explain it to you. So there's a difference between inductive proofs and deductive proofs. Deductive proofs are absolutely true and certain. In all possible worlds, 2 + 2 will always be 4. In science, the Earth revolving around the sun could be true in some worlds, possible worlds, and false in others. So it's possible that we could be wrong about any
But not
or
in
all
science.
of our. In science, it's possible we could be wrong about all of our beliefs. It's just not very likely. But we can't be wrong that 2 + 2 = 4. That is true in all possible worlds.
Do you have a margin of error on that likelihood of you being right?
I would say it's extremely high for certain beliefs and more in the middle for others.
And where do you get these figures,
it's
these
likely
numbers?
in
Where do they
all
come from?
worlds,
You just made them up yourself?
I didn't hear either of you.
I just wanted to. You said it's likely in all worlds. Is that in mathematical Hmong world? It's likely as well.
No,
And where do you get these numbers, these figures?
Is that just as likely in Sabine Hossenfelder's world?
So possible.
Brenda, you got
So
an
the
echo
language-
going on, I think. Hold on. Somebody's got an echo.
It might be me. I'll put headphones on. I apologize.
That's all right. Thank you. Yeah, I'm confused about this worlds thing too. What other worlds are we talking about here?
Well, the only point I said is I think it's Farming Ganja put the link to Sabine Hossenfelder earlier.
So,
which is which I was talking, Brenda. Just come on, calm down. I know.
Oh, I'm sorry. I'm sorry. I have headphones on now.
I know. Well, are they working? Did you hear me speaking? Are they working now? Am I okay? Brenda, can you hear me?
I apologize. Go ahead.
I didn't ask for your apology. I was checking if you was all right, Doc. No, I wasn't after an apology. You said in all worlds, 2 + 2 = 4. Yeah. Farming Ganja's just cited one of the mainstream's eminent nutcases, Sabine Hossenfelder, where she questions that within your mainstream.
Yeah, I don't know what she said, so maybe you could put it in your own words.
Yeah, this is what
well, probably maybe Farming Ganja's probably best.
the science communicators are there to teach people agenda the science, and they ignore it.
So what possible worlds means, it's modal logic. Modal logic is the logic of possible worlds, right? So it's possible that
Brenda, I thought we were going to have a point of agreement here, just for once. Do we both agree then that Sabine Hossenfelder talks shit?
No, she's very intelligent.
You basically just said that 2 + 2 = 4 in all worlds. She's saying that's not necessarily the case. Do you agree with me then that she's just full of hypothetical nonsense?
I don't know what she said, so I can't say.
You don't know.
You have a look at it.
Know the science. You have to learn the science first to understand what she's saying.
No, I don't have to learn science. What she's saying is mathematics, not science.
Just to even understand where she's coming from requires at least a high school degree. She's even said that.
I don't know what she said.
I get it, because you need to go back to GED.
So maybe you could tell me what it is she said.
No, if you can't even understand her, a paid professional educator, what do you think? What chance do I have?
I understand her when she's
talking.
You don't.
You just said you don't.
I didn't say that. I said I haven't heard what she said about this topic. All the videos of her I have seen. I've not seen all of her videos. As far as I can tell, she's very intelligent and highly informed physicist.
Yeah, and she said flat earthers are wrong, right? Not stupid. And you hear stupid. See, that's you being stupid.
But some flat earth, I think
your brain doesn't work right. You need to get fixed.
No, that's not what I said.
And educators can't do it. So you need remedial training.
No, that's not true. So
yes, it is true.
I think that
if the educators are telling you something and you hear the exact opposite, you need remedial education.
Well, maybe you could educate.
A little bit of shock therapy.
No, if the educators can't educate you, there's no chance I will be able to.
Well, educate me then.
Okay, listen. If they can't do it, there's no way I will be able to do it.
Who said they can't do it?
You will hear them say X, and you say the exact opposite. Negative X.
Could I have a link?
That level of stupid is beyond fixing. You need to fix it yourself.
Yeah, that's fine. Could I have
and
a
it could
link?
require lobotomy or some sort of radical brain
I know
surgery.
you have fantasies. So could I have
Yeah, you got fantasies too. You got someday you think you'll be in space because you've blown so much hot air, you'll fill your own hot air balloon and then fly away.
I will probably never be in space because I'm much too old. So could I have a link to where Sabine says this so I can look at it myself? Please.
Yeah, go look at yourself.
I just sent it to you.
So anyway, so we've been talking about this for 10 minutes. Does anybody feel like they understand how science is reality or whatever the fuck it was Brenda was telling us to start off with? Because so far it feels like we just chased our tails for 10, 15 minutes.
That's kind of the point of the globalist. The globalist is the spiral. So
all I said was I wanted to bring up something about how we see some stuff or whatever. And he started off with,
Why is it so difficult?
Yeah, because you misunderstand how the human visual
I
system
didn't even
works.
say what I want to talk about. Like specifically, I gave a broad category.
But Bob, I was here over the weekend. I saw. I understood.
You weren't here with me and Bob when we had our conversations.
You were not capable
It was
of
just me and him.
understanding how perspective works.
And then, like later on, there was some other people or whatever. But
So, what is it you
Yes,
think
it
that
was-
Bob doesn't understand, Brenda?
They think that a perspective causes things to disappear from the bottom up, and that's false.
I didn't make that claim even one time the entire weekend. By the way,
Many flat earthers, including the Nathan Oakley variety, think that that's what happens.
my name isn't many flat earthers. That's not my name. So it wasn't me. Whoever you're talking about.
Okay,
Overlapping happens though, doesn't it, Brenda?
No, it doesn't.
What do you mean? No, it doesn't. A wave
it
can't
doesn't
overlap
happen.
something in the background.
Right. So there is a straight line for an object on a flat plane and an observer. There's
With
a straight
a rough Earth and topology, yeah.
but we're just saying a flat Earth.
There's
Hypothetically,
no such thing as a completely flat surface on anywhere
but
on Earth.
nobody thinks that flat Earth doesn't have topology. That's not what we're talking about. So on a flat surface,
That wasn't his point.
there's a flat
that's dumb.
surface.
That's bullshit. Already the bullshit.
On a flat surface.
Say it again. Maybe Brenda will get it.
I would like to complete the sentence. On a flat surface.
But you're already fucked up. Everyone can see it.
You're going into imaginary land and saying reality
I'm not.
doesn't match imaginary land.
I'm saying
Name one
on-
place which is completely flat.
On
Anywhere
a-
on Earth.
On a flat surface, there's
Holy
a straight
crap.
line connecting.
You are just brain fucked right now,
connecting
dude.
every
Look at
point
you later,
from
finish.
the object.
Because it's
There's a-
already wrong, dude. What surface are you talking about, Tron? Did you teleport yourself into the video game,
Minecraft!
Tron? What the fuck is wrong with you?
Yeah. So on a flat surface, there's a straight line.
Start screaming like an
All right.
idiot.
So in
There's a
Minecraft,
straight
there's a straight line. We got it.
There's
Okay.
a straight line.
Yeah,
connecting-
Minecraft. See, I said Tron, Minecraft. There you go. Brenda's favorite
say
game.
crit.
Walk around the Minecraft. Where the hell is the
Hey, don't diss
tutorial?
Minecraft, okay?
You have some manners, please, and learn how to do conversations,
Yeah,
please.
how about you do it?
No, I'm not the one interrupting. You're interrupting me.
learn how to hear somebody
You've
say
been
broad
destroying the
category
show
and then
for
just ask
15
why is
minutes.
it so hard.
Brandon, please.
Oh,
I'm
sorry.
not talking over people. I'm not talking over people.
You've been sitting on the show for 15 minutes. It's boring. It's stupid. The Brenda
because
show can
you
go fuck off.
You keep interrupting me.
All right, let's give everybody a chance to talk. Let's hear about this imaginary world you're going to tell us about.
So the way that perspective works is things get smaller in the distance, but they will never disappear on a flat surface because there is a straight line connecting the observer with every point on the distant object. It
No,
will
that's retarded.
never. So an object on, say, a kitchen table will never be obstructed by the table, ever.
Can
Oh, that's
I
true.
share
Yeah.
my screen, Brandon, please?
Of course.
Whenever we're ready to have the conversation I was talking about, I put some pictures up here that we can mess with or whatever, or I can mess with.
Can you see that?
Yep.
Yeah, I'm not going to play it because it's National Geographic. So, but we all know this one, then,
Oh, hold
Brenda.
on, Gleam. I'm sharing the wrong
Yeah,
one.
this will get
Before you get started. Sorry about that. Go
Yeah, I'm
ahead,
not going to
there's-
play
This
it.
video
That's
is
what I'm
taken-
saying.
It'll be
I'm not going to
taken
play
down
it.
in a heartbeat, probably while you're
I'm-
going live.
I'm not playing it. I've took a screenshot.
I've actually
Okay.
played this clip before, and I didn't get.
And
Oh,
he hasn't
that's
been.
cool. That's cool.
Okay, but I'm not going to play it.
Yeah, don't.
Just in case. Who cares? We don't need to play it. We're looking at a flag, Brenda. I don't know whether you've seen this video
No, it's
before.
not a flag. It's isn't it a piece of wood that's been painted red, black, and white?
Well, it's material on the
So
wooden
not a
frame.
flag.
Yeah,
Not a flag.
it's similar to a flag. Come on.
So it's not a flag.
Oh my God.
What
Okay,
does it matter,
so
Brenda? Stop doing this.
it's a bit of material on a wooden frame, not a flag. Okay. However, there is an equal amount of red and white at the top as there should be at the bottom. However, it's hidden bottom up. Why?
Most likely, I'm not familiar with this, but possibly due to curvature, right?
So what's that in the background then? If it's going
That would
over the
be
curve of Earth,
the horizon.
so it's not going over the horizon.
Well,
Yeah, I think
the horizon can be refracted, and it can
Isn't the
give-
So
curve
there's
of the
two.
Earth the horizon?
So there's two.
it-
There's two. There's one
there's
here
two.
and there's one miles back.
Yes, one would be the geometric horizon. The other would be the apparent horizon.
Are you sure that's not just a wave there, like where you see the crest?
Well, I don't know the height of the observer, so it's possible that's the
It's
wave.
on the beach. It's on the
But
beach.
if the
Literally, they've
observer-
got the camera crew on the beach.
If the observers are higher than the waves, then it can't be a wave.
Yeah, personally, I think that this is not unlike the black swan image
But
where you see all the
you're not
refraction.
answering my question. It's complete
Wait, wait.
avoidance.
I thought I did.
No, I mean, you said it was the curve of Earth
Yeah, possibly.
that is hiding this. I would really love to play it because this comes more apparent, then less apparent, more apparent, less apparent.
Oh, well, then maybe it's a wave because I don't know the height of the observer.
Well, that's what
Hold
I
up,
just
hold
said.
up, hold up,
That's
hold
what
up,
I just
hold up.
said exists, and you just said no, it doesn't.
So she's just gonna emit her waves now, like nothing?
I don't
Yeah,
know
she-
the height.
she-
I don't know the height of the observers. I don't know the
He doesn't
situation.
understand, y'all. Let me give another example. Okay, from Jesse Kozlowski went out there with Tim Osmond. Okay, and he was, to their shock, when they got down to 6 feet above the Great Salt Lake. To their shock, the half of the mountains were covered in the background. Okay, they were 6 feet above the water, the lake. Okay, what was covering half the mountain?
Tim
to their
Osmond's,
surprise.
Tim Osmond's photographs from the Great Salt Lake clearly show obstruction due to curvature.
No, they don't. They show obstruction, and you interpret it as curvature because you want to, so it fits your ball fantasy. That's how that.
Well,
goes.
you asked me what was you asked me over a flat surface, so I knew I dare not give an example that I have. So I'm just going to some of your
I don't
buds. You
care.
know?
It doesn't matter to me.
So
It
when
doesn't
he-
matter to me.
Well, you clearly don't understand it, so I'm trying to fill you in. Okay, so they were 6 foot above. When they were looking at the drones, they could see the whole mountain in the back. But when they got down with the auto level, wasn't a camera, it was an auto level, and they set it up 6 feet, they were missing almost half of the mountains in the background, like I think 28 miles away, but the water was under their feet. Why was it blocking the mountain?
Because you would expect that on a curved Earth.
So
just like-
you clearly
it's just
don't
like the-
understand optics.
It's just
Sorry.
like that's not how optics work. It's just like Ranty's black tower. It's the same thing. The mountains in the distance, they're the bottom of those mountains is like about halfway up the picture.
So do you think Jesse set up the auto level wrong, or Tim? Do you think they set up the auto level wrong? They're looking out
I think that-
horizontal, and the water was above the crosshairs. So you said on a flat surface,
I think that
it couldn't be curved. So even on a curved surface, okay, the water can be up above the horizontal.
I think that
maybe
you
not
just-
every day. What?
I think that just like the Blackpool Tower, which you didn't understand, you probably don't understand this either.
Okay, so give me what don't I understand about an auto level looking out in the distance? It's a mountain set up 6 foot above the Great Salt Lake with the water above the crosshairs. What's there not to understand, Brenda? Please.
So how can the mountains be lower than the Blackpool Tower?
Answer my question, please. What
Yeah,
could be? What could be?
They are over the curve. The mountains are over the curve.
No.
By
No, the
1,000
water
feet.
is above the crosshairs. The water was above the crosshairs.
Yes.
Here it is, Brenda. It's called refraction. Okay, and it happens. Okay, nothing's stable at them big distances, especially in places like Salt Lakes, beaches area. But you get waves, so you have perspective with refraction. There's a lot that goes on. I'm just trying to teach you so you can understand.
But the amount missing is greater than it can be accounted for by
Yeah.
refraction. Like in the Blackpool Tower,
Well, I'm just
the mountains
speaking of
are below
I'm speaking of
the
your
tower.
I'm just speaking of your statement that nothing can the flat surface. Nothing can obstruct the background on a flat surface.
It's
So-
physically impossible.
Then how can it do it on a globe?
Because
if the flat
surface
ground
is-
can't block it, how is the ground curving away from me blocking it? See, you're choosing not to understand. You're offering any resistance to anything I say instead of understanding what I'm trying to tell you.
Because the surface is curved. That's how.
That doesn't make any sense.
Why not?
You're not even following his argument. He's saying something so benign and so obvious, and you still have to fight against it.
So if I have, say, a hill, and there is a distant tree, and I can only see the top of the tree, the rest of it is obstructed by the curvature of the hill.
No, it's not. It may be obstructed
It's
by
not?
something, but it is not obstructed by curvature. That is your interpretation of what you're seeing.
Then what's obstructing it?
Could be physical, it could be optics, could be refractive phenomena, could be a lot of things. How did
So optics-
how did you determine that it wasn't anything else?
Well, it conforms to the predictions made by the globe model. The globe model makes predictions that can be verified by making subsequent observations, right?
The globe model's dead. Okay, it's crushed. Your geometry is done for. Even
Well,
the ballers
I'd like
reluctantly
to-
admit that there's no more geometric horizon because they have to argue refraction now. They have
that's
to.
wrong.
They have to claim
Brian, I
refraction
measured the
with the.
curve. I measured the curve. The curve's there. I mean,
Guess
that's
what, Bob? Go
fine.
out there tomorrow and see what you shoot over 2,500 feet. You're about a 5-6 inch difference just between afternoon and evening on
No.
a daily basis over half a
No,
mile.
I
How
did
did you measure the
several
curve,
days.
Bob?
Directly measured the curve.
How?
Did you see the
Bob
video?
did not.
No, I didn't. I'm asking you to explain it.
Okay,
There's
watch
probably a
the
lot of
video
people
and-
who are listening that haven't
Watch the
seen it
video
either.
and you'll see.
Okay. We're having a debate about this right now. but-
Okay, so right, so I'd be more than happy to talk to you sometime, Brian. You can send me an email, and I'll set up a StreamYard stream, and we can talk about these things if you like. But the fact is,
It'd
that
be
there's-
hard to commit to that because you just said on a flat surface that anything under eye level can't block something in the background. And I gave you an example of somebody on your team, and you won't even acknowledge it. So if you don't even understand that, why would it? I mean, you need to learn the basics before we have a conversation, right?
Brandon, if you want to put this to rest, go ahead and show the video. I'll be here for a few minutes if you want to discuss it.
Can you explain
Bob, I
what
could
you
show you a
did in
video
your
like
video,
that.
Bob? How you measured curvature in your video, please?
Yeah, I compared two equal elevations above my lake level on each side of the lake, and I verified them with an auto level. I shot a line directly between the two of them, and there's a drop to the other side of the lake.
So optically.
Yeah, with a device
So that's-
designed to optically measure.
Indirectly.
You started this off by saying you directly measured curvature, and you just
That is a
described
direct measurement.
indirectly
Yeah.
interpreting what you
direct
saw
measurement.
as curvature.
If you did something optically, you weren't measuring something.
That is a direct measurement.
No, it's not.
The black swan
That's
has
called
debunked
eyeballing.
the black swan's debunked any kind of optical measurement you guys think you're about to make. The black
That's
swan's
silly.
debunked it. You're fine.
Let me bring up my
All right,
video.
I'm very
Mr.
curious.
Sensible
If you
said
don't
this
think-
debunks a radius. So
All right,
there's
I
got to
think
be a
that,
different radius.
you know, here's something that's very interesting. If you say that an auto level which is designed to specifically measure level optically, is not a correct measurement. How exactly do you expect us to measure the drop of the Earth?
Can I answer
You want me
that,
to
please?
bring a
Small
yardstick
increments.
out,
We
perhaps?
don't expect you to, because
How
it's
do
not
you
there.
No, what is
How
the
do you measure
standard
a
that you want to
unicorn?
hold it to?
Differential leveling. You want
What
to do
is
it
the
properly,
standard
you're going to use
measurement?
differential leveling.
Yep.
Differential
And-
leveling does not measure the curve of Earth.
Hang on, Bob.
You're right.
Exactly.
It doesn't, because it's
'Cause
not
it ain't
there.
there.
It's not
Bob, what was
designed
the
to measure
distance?
curve of Earth.
Yeah, that's right. It's not. Because why would you want to measure something that's non-existent?
Look it up. It's the most accurate way to get elevations. And even with lasers, differential leveling, with auto levels,
But
and the
that's optical,
GPS,
though, isn't
differential
it?
leveling is the most accurate method they have. Look
But
it
a
up.
differential level's optical, isn't it?
Yep, and within the
All right,
tool
so why is
limit.
that
Okay.
optical okay, but my optical's not okay?
Not you're trying to use 2,500 feet shots.
No, you objected to it because it was optical, and then you cited an optical measurement. Do you not see a problem with that, Brian?
I'm telling you the facts, what I've researched and what
Do
I
you
can
not
pretty
see
much
a
what I do
problem
on a daily
with-
basis, bro.
Do you not see a problem with saying an optical measurement is not adequate, and then saying another optical measurement is the way to go? Do you not see?
Is that what he said? Is that what he said?
Say that?
Maybe so.
I don't know that he said that. I said that. I said optical measurement isn't a measurement, and
Hold
I
on.
Let me
stand
say
by
you
it.
something, Bob, real quick. Let me say one thing,
All right,
Bob.
so if you
Bob,
don't want to use
I'm going to give you an
optical
example.
measurement, how do you measure the curve of the Earth?
Hey,
You don't,
let me
'cause
give
it's
you
not
this,
there.
okay? Your measurement, okay, that day for that minute appears like there is about almost 2 inches of drop over half a mile with that one shot. Okay, 4 inches.
Yeah.
Okay.
What was it 2 days later?
Brian, can you give me a second,
Okay,
please?
now let me tell you.
What was
Okay,
it 2 days
okay,
later,
just a
Brian?
moment. Now, what would you say if the Great
What
Salt
was
Lake?
it 2 days later, Brian?
What would
Same
you say?
thing.
I don't know. I didn't see it 2 days later. Okay, listen. Now, what would you say if you were looking out with auto level 6 foot above the Great Salt
What
Lake?
do you mean you didn't
And-
see it 2 days later? It's right in the video.
I didn't watch the whole video.
Well, that's your problem then. Go watch the whole video.
Okay, so do you think that proves Earth curve, Bob?
My mic real low?
We'll be good to go.
No, hold on, Rob.
I'm wondering if this dipshit thinks that proves Earth curve because I got an auto level.
Rob, let's let Rob say what he has to say. Go ahead, Rob. Then I got.
I just want to ask Mr. Bob. He's using an auto level.
You want me to get my dad?
No, just relax.
Then
Bob,
use my correct
You're
name.
using an auto level, right?
Yeah, he said auto level.
Yeah, Anthony? You said yes?
Yeah, that's what
yes,
he said.
there's
Yeah,
an auto level. Where's your grade rod?
Right in the
You
video.
don't need a grade rod. You don't need a grade rod to do the observation over
Then
distance.
you're not
Right
using
in the
the tool
video. Did you
correctly.
see it?
Game over.
Did you not see the grade rod?
That's fine. We don't need a grade rod, right? So this
But
image
did you
that I'm
see it in
showing
the
on
video?
screen right here, which is geometrically impossible on a globe, which is you're telling me that you take a measurement that lines up to the globe. Here's a measurement that lines up to a flat
I'm
planar
only
surface.
addressing my measurement.
Oh no. Let's talk about this one because if yours is valid, then mine's valid.
No, I'm only addressing mine because I know
that's
how
not
mine
the way
was
it
made
works,
and I
Bob.
documented
That's not
it.
how science works, Bob. If you have to consider other
All right,
things that might
where's your-
falsify your
All right,
science,
where's your
Bob.
data here?
Huh?
Where's your data here? Where's your data? I want to know the
it's all-
elevation. I want to see your datum to the level of the water.
It's
All right.
in this video. You're not familiar with
No,
this?
no, I want to see you do it. I want to see you do it with a rod. I want to see you measure the distance.
We don't
from
need a
the
rod.
camera
What
to
are
the
you
water.
talking about? We just determined that we don't need a rod, right?
Your
Howard?
video isn't.
I have a rod, and I did the
Okay,
measurement.
so do it for us right now, like you're requesting.
I did. It's right in the
Okay,
video.
and these ones, this
Well-
video, you're saying go to your video. He's saying
Right.
go to this video. If the video's not good enough, then it's not good enough. Then we agree it's not good enough. Now do it in front of us
my
because the video's
measurements
not
are
good
all
enough.
in my video. My
Well,
measurements
hold on a
are
minute,
directly
Bob.
in my video.
Why are you throwing this
Isn't
evidence
this
out?
so that we will
Hold
watch
on.
your video?
Bob, why are
Yeah,
you
you
throwing
gotta
this
watch the
evidence
video.
out? Why are you throwing this evidence out?
Where is the elevation above the sea level that is documented? Where's the documentation of the
It's well documented in here. He's got all of the data in here.
No, show me where it is by measurement. Show me the measurement to sea level from the camera.
See rules for thee and not for me.
Yeah. Okay. So you're going to try to get out of it on a technicality then, Bob.
Level. Where's your measurement to sea
level?
level?
Do you think this gentleman was lying about where he was?
Yeah. Yeah.
You do?
Yeah,
so
I have no way of being able to tell where he was.
That he's not lying.
Oh, well, I mean, that's fine. If that's the standard, then you're a liar too, and now we don't have to consider what you put out.
Anything.
Sorry?
There's no standard in that video where he actually measured anything. There's the standard where I measure everything in my video.
This sounds like a convenient excuse for you to ignore this video, Bob.
Well, first of all, I've already reviewed that video, and I'm not concerned about it. But my video
why aren't
has
you concerned
actual
about
measurements in it. Because
arrogant dick.
Why aren't you concerned about it,
My
Bob?
video has actual measurements in it.
Huh?
Oh, you say that, but if your
is the guy a liar, or was he standing where he said he was standing, looking out where he said he was looking out?
That's what I'm discussing. I'm only discussing my video, and my measurements are literally in there for you to see.
You can't only discuss your video. I'm bringing something up. Okay, Bob, I accept your video and the measurements that you made them correctly. All right. And that your methodology was good. Now I'm showing you a piece of evidence that invalidates your interpretation of those results. And you're ignoring it.
No, it doesn't. No, it absolutely doesn't interpret.
Of course
it doesn't invalidate. How much of that platform's missing, Brandon?
You can see the horizon beyond the platform, Bob.
How much of the platform itself is missing?
Missing where? I can see.
Where's the boat dock?
Appears that I can see to the bottom of the platform.
Where's the boat dock?
I don't know. I can't tell the details.
Point it out
to
me. Point out the boat dock to me at that far platform, please.
I cannot see a boat dock here. I can't make it out.
Correct.
It's very.
You can't see 15 feet. You can't see the lowest 15 feet because that's the elevation of the boat dock. What's the lowest object you can see on that oil
Why
platform?
can we see the horizon beyond the platform, beyond the first platform, and definitely beyond the second platform, Bob?
It's a false horizon. Tell me what is the lowest object on that platform.
Of course it's false.
No, tell me what the lowest object on that platform you can see
Of course it is.
Well, point it out then.
This water has waves. Let's not even talk about the horizon. Let's talk about the water in between platform, the front platform and the back platform. Is that false too?
Now, Brandon, unless you're going to
Is that water false too?
Brandon, unless you're going to tell me what the lowest point on that far platform is, we're done talking.
That you're trying to wiggle out the technicality, and it's very transparent to everyone who's listening. Just so you know.
BLSMB just put out another video a couple days ago.
Point out the lowest point on that platform, please. What's the lowest thing you can see on the platform?
This black right here.
Great. Where's the boat dock on the far platform?
Just point out anywhere.
I can't make out the details, Bob.
All right. Where is the boat dock on the far platform?
Why do you keep asking the same question over and over again, even after I answer it? I've answered it 3 times.
How much of the cross beams can you see on that far platform, Brandon?
Check his most recent video. Check his most recent video.
Brandon, can you see where the cross beams cross on that far platform?
Bob, you already exposed yourself as a disingenuous.
Well, I'm still beating you though.
Scientist, just so you know.
Brandon, may I say something?
You though. On the far
just point out anywhere in the picture. Point out anywhere in the platform.
Okay, here.
Nobody can make up.
All right, right there. How high is that above the water? Right there.
It's right in the water.
The water's right here, and here's
on the platform. How high is that above the water?
You cannot see it because the details are missing.
0.
It's too far.
It's 0 above the water.
That's not true, though.
It's not. That's about 25 feet above the water. You see the cross beam just to the right of your cursor, just above it and to the right.
Right here. This what you're talking about?
That
Can I ask
beam
a question,
goes
Brandon?
diagonally from the upper left corner to the lower right corner of that gap right there.
Yeah, it looks like it goes from here to here. Yep.
Quick question. Just how many pixels should 25 feet take up at 9.3 miles based on unknown atmospherics between here and there.
What you can
How many
see
pixels? That's a bold claim you're making. You're saying that clearly there's curvature at that point, even though the ground appears to go up after that point because the horizon is where it is.
Point out the lowest point on the oil rig and tell me
how many
high that is off
pixels?
the water.
How many pixels should 25 feet take up at that point, excluding
your
the fact
job,
that
not
there
mine.
might
I'm
be?
looking at the
There
oil
might
platform.
be. Let me finish. Excluding the fact that between the 6 and 9 mile platforms, there might be a wave that's actually creating a physical obstruction, like your supposed curvature, that's obscuring that little bit.
That can't
How
happen.
have you
That
determined
can't
that
happen.
isn't the case as well?
Waves don't
We're
happen in
above-
between
because we're-
platforms.
No, because
How
we're
far
above
is
the
it?
waves.
All right, so show me where the cross beam is.
He's just gonna
And
repeat
tell me
himself
what is
over
the
and over
lowest
again.
point that you can see on that platform.
You're stuck.
Yeah,
Hit yourself on the side of the head, Bob. You're stuck.
They are so
So-
close-minded.
Shake.
They're
Like,
so
jump up and
close-minded.
Because I'm destroying your argument. What's the
No,
lowest
you're
point
not.
on that
Repeating
platform?
the
you're
same
not,
thing
Bob.
over and over is not destroying an argument.
Because, well, yes, it is
20 to
because,
25 feet of that platform's missing, period.
No, it's
because
not.
he's pointing, Brandon, he's pointing out that the cross beams on the platform are above the water line.
Meanwhile, you're
Like
ignoring
25
that
to
you
30
can see
feet,
the
actually.
surface of the ocean between the two platforms, which on your curved ball Earth, you shouldn't even be able to see. Yet you're telling me that this in front of this ocean that I can see in between them is hidden by the curvature that's not hiding the ocean behind it.
What's in
Do you
the
see,
way?
do you see that? Do you see how that's a contradiction there? You're telling me that there is a curve edge here, but there's a horizon behind
right.
it. That
There's
doesn't make any
something in-
sense.
Right. There's something in the way. There's something in the way. What is it?
No. This
Yes.
video right here destroys your
destroy
optical
it?
evidence. Period.
No, wait. I
No.
want
It
to
actually
look at.
confirms it. But
No,
thank
it
you.
doesn't.
Yeah, look
What's
at look at
lowest
the
point on that
horizon.
platform you can see.
If somebody mentions
the
the bendy
horizon
crane, I'm gonna
below.
fucking barf.
Look
All
at the
right,
horizon.
Well, and you show me something below 25 feet above the water line on that platform.
But look at the horizon
The
itself.
shadow. How about the shadow on the water?
Look at the platform.
If,
Show me something
you-
on that platform that is below 25 feet above water line.
yeah, if you look parallel to it, to the left of the first platform, but along the same line as the first platform, you'll see there's a little duck, and it's definitely on the waterline. And I can see that. So there must be a wave in the middle blocking the thing that you think proves curvature. Even
And
though
how
the
high
water
is that
continues
little? How high is that little
flat
bump on the
behind
left?
that obvious wave. It's quite
How
clear.
high is the little bump on the left above water level?
It's hard dealing with drunk Bob. Drunk Bob's tough to deal with, y'all.
You need to look at the duck. It's clearly
Yeah,
there.
gotcha,
and it
guys.
shows it there.
Gotcha.
No, you didn't
Why-
get us, Bob.
Yeah. Why are the cross beams, which are 25 feet above the sea, obstructed? What is in the way?
Well, it's not
The
curvature, is it?
wave that the duck has
Yeah,
just got
why
out of the
doesn't
way
the
of.
camera have infinite resolution, guys? Why?
Brenda, you wouldn't answer what's blocking half the mountains above the Salt Lake.
Hey,
You
guys.
want what's blocking half
Yeah,
the mountains?
Brandon, I'm sure.
He
above the
just
Salt
pointed
Lake?
out here in this video, I can see this cross beam, so I don't know what you're talking about. Is this the cross beam you're talking about? This right here that he's pointing out right now? Is that what you're talking about, Bob?
Yes.
Habitat's lower steel cross beam support visible. Yes, it is. It's right there.
Yeah.
Not all of it.
How do you
Above the
know?
water
It's all you can't see it very well right here. How do
Is
you
the
know?
bottom-
It looks
Pull
like
up
it
the
goes right
construction
down to
document,
here, right
Brandon.
down to the water.
What's the shadow?
Is
Go
the
ahead
bottom
and pull
half-
up the construction documents, Brandon. I did.
Scrambling now because the horizon's way behind all of that.
Yeah.
That's all
Is-
that matters.
No,
the
yeah.
habitat.
I mean, they
Hey,
want to
Brandon.
ignore that. I was
right.
giving them that.
Well, I
but-
just read
Explain
your
that.
argument, Brandon. If you want to pull the construction documents up as I did, you can see how
Bob.
high that is.
Bob, no,
If
you
this is
didn't.
what it takes to be a Glover.
I mean, you're
Is-
looking
I'm
at the
embarrassed
evidence
for
here
him.
that refutes your supposed direct measurement of curvature, and the excuses you're making up are just like paper thin.
Can I destroy him? I've just knocked it up in
Is-
Photoshop,
Yeah, do it.
and
Are
the
the-
proportions work perfectly fine.
Are the lower half of the cross beams underwater?
No,
then why can't we see the lower half of the crossbeam?
Just go ahead and point them out right out, Brandon.
Here's the crossbeam right here. You can see it.
Yeah,
Come
that's
down
the-
right
Show me the
there.
bottom half of it, Brandon.
What?
Show me the one that goes the other way.
Did I get
Why?
kicked out?
Isn't one enough? Don't they intersect in
No.
the middle?
No.
They don't.
Show me where it intersects.
I can't see the detail in here, obviously.
All right. Well, until you can identify properly the lowest point on that platform that you can see, you don't have an argument.
Well,
It looks
until
like
you
Liam's
can
stream here
refute
is
this visual
totally
evidence,
debunking that.
this
live.
falsifies your
in real
supposed direct
time.
measurement of curvature, Bob.
Yeah, ask the
All right,
retard
let
if
us
the
see how-
Earth
okay,
curve is a
we'll
roller
make it a little
coaster because
easier for
the
you,
horizon is way back behind the.
You want me to go ahead and make it easier for you, Brandon? You see the bottom deck of the platform. Now, if you look at that picture of the platform, you see the bottom deck of the platform has the yellow lights going along in a line.
This right here, yeah.
All right, how high is that off the level of the water?
I don't know how high.
57 feet.
Okay.
Now, above it, do you see the helipad, the flat area above it, above that dark block?
The helipad.
On the right-hand side.
Sure, over here. Sure.
Well, according to the FAA, that helipad is 90 feet above the water.
Okay.
So, you go from 57 feet to 90 feet. Does that look like does that difference look
Does
like
that sea level
between the
change at
surface
all,
of the
you
water
dumbass?
and the bottom of the deck?
No.
Gotcha again.
You know what? Why do you think it would be perfect proportion when you're looking this far? This is the whole argument in a nutshell is that
Because
things look
that's-
fucked up
What's
when
the
you look into
bottom
the
of
distance.
what's the bottom at what elevation above sea level is the bottom of the cross member portion of the support platform?
I don't
Where do
know.
you stop seeing the surface of water, Bob? Bob, where do you stop seeing the surface of water?
I'm talking to Brandon now. Don't interrupt.
Not until here
Now,
on this horizon.
How high?
I
How
mean,
high
Bob,
is the cross
I
portion
can't sit
of
here
the?
and talk about this bullshit without you getting to a point until you at least acknowledge that we can see the water up to and past this second
That's a false
platform.
horizon. That's a
The
false
whole
horizon.
thing is a false horizon. The water in between the two
Yeah, notice
platforms
the
is a
difference in
false
color.
horizon too.
Do you see the difference in color?
Is the water between
It's
the
the
two
surface of
a
water.
false horizon?
All right.
Yeah,
well, do you
I
see the
can see
difference
the
in
difference.
color?
Bob,
Yeah,
is the
sure
water
Yeah, I can
between
see
the
that.
two platforms a false horizon too?
No,
Okay, so that right there falsifies your globe then.
no, it doesn't. Doesn't
Sure it
even
does.
remotely. How thick? How thick are those cross member? How thick is that cross?
Why are you
member
talking about the
support area?
cross members? We've got a much more obvious problem here.
No. We're measuring. We're measuring.
No, we're
things.
not.
actually
We're not
doing
going to go
science,
to this
Brandon. We're
grainy
measuring
image
things.
10 miles away and try to
Well,
see
you're
the
presenting it
details
as
that we
evidence,
can't
so we're
see
gonna
very
measure it.
well on an image that's very
No, you're
likely
presenting it as
compressed and
evidence, so
screwed
we're
up
gonna
at that
measure it, Brandon.
distance and act like
All right,
that
well, I'm done.
falsifies anything. That's
Well, I'm done
ridiculous.
talking to you if you're going to talk over me, Brandon.
Well, maybe you should wait until I'm finished talking and then you can start talking.
You're definitely done, bro. We can see the surface of water.
Yeah,
All
he
right,
needs
how
an
thick
out
is
now.
the,
He needs an out.
cross-membered- How thick is the cross-membered portion of the supports? 17
Stop
feet.
talking about the cross member.
Yeah, 17 feet. The distance from the deck to the helipad is 57 to 90 feet. That's 37. That's 33 feet, right?
How many miles between the two platforms am I seeing the surface of water past where the
Irrelevant.
globe geometry
Irrelevant.
says I should be able to see?
Irrelevant.
Irrelevant.
Now, you have to tell me how
How is-
low
how is
the
that irrelevant,
lowest
Bob?
portion on that platform is.
How's that irrelevant?
It's only irrelevant because
I
it
can
ruins
get down
his
to
argument.
about 40 feet above the ocean. Can you get lower than that?
How is that irrelevant?
What do you see on the platform? I don't see anything below about 40
It's
feet
very
above the ocean. Can
obviously
you see
obvious
something
that you're
lower?
trying to obfuscate with this platform shit.
No, I'm staying laser focused on point. I cannot identify anything
No,
on
you're
that
not, Bob.
platform
You're losing
lower
badly.
than 40 feet above the surface of the water. Can
Bob,
you?
There's no compression, Bob, at all, you think?
Go ahead and identify something lower than 40 feet above the water for me, please.
Okay, I
Okay,
posted a
the
video in
water.
general.
The surface of the water is lower than 40 feet.
Show me something on that platform.
It has to be on the. Why does it have to be on the
40
platform?
feet
I'm
above the
showing
water.
you water, the surface of water between two platforms that you're not even supposed to see, and you're
Sure you are.
focused on the details on this platform, this fuzzy.
Well,
platform.
we are going to focus on the details on the platform because none of you guys will. You have never looked at this photograph with a critical eye.
Platforms out completely.
Rubbish. We've calculated it here on Ranties
Okay, well,
before.
go ahead and show me the lowest point on the platform that you can find.
The platform has nothing to do with the image at all. They're only mile markers.
Absolutely has everything to do with the image.
It's about the horizon.
Platform only
Great.
gives
How
you a
far is the
designation of
horizon?
distance.
Further than the platforms.
How far?
Much
Give me
further.
a number. Give me the exact number.
9 miles.
Nope, the platform's 9.41 miles away, so the horizon is not
Okay,
at 9 miles according to you.
It's
then,
way past.
Okay, how far?
15.
Okay, sure, we'll go 15.
And where did you come up with 15 miles?
We could actually calculate that.
Go ahead and give me
tangent.
Go
Clean,
ahead and give me an actual measurement to 15 miles on that horizon.
The
Is there an
height
object
divided
that's
by the
15 miles
tangent
away?
of 0.02 degrees.
Does anybody have a picture of Ranty's Stenoliner? That one, real quick.
No, but he's trying to get us to calculate something he knows is ridiculous.
Also, I
thing to
just did the
calculate.
triangle calculator. Hold on. The triangle calculator, something 20 feet above the oil rig, is at 0.02 degrees. Okay. And I got a picture of Randy's compressed Stenoliner also.
All right. So go ahead and what's the lowest point on that platform you see? 40 feet above the water? Where's the rest of it? Where's the rest of the platform?
Bob, if I jumped off that platform into the water, would you see me hit the water, Bob?
No, because it'd be hidden by the curve of the earth. Thanks for playing into my hand there.
That makes you fucking retarded. I'm very sorry that you're being unreasonable, but
I agree with that.
If I jumped off that platform,
that was a lot of
if I
fun,
jumped
guys.
off that.
Thanks much.
No, he's right, Bob. It is like a retarded thing for you to say.
No, you won't see him even if he stood on the platform.
What?
If he stood on the lower deck, you wouldn't see him.
There's
He's
a
not
bunker
there.
with
It's
seals
under the water.
on top of it, and another picture.
I posted the picture.
Buoy. I can see the buoy. It's directly on the water. I could.
Brian, I posted a picture of the platform. You see the cross that Bob was talking about. We see only its half top.
There you go, guys. Read it and weep.
Are you guys retarded? Because this
What
should not
retarded? You see the
look
cross
like
there?
it's above this,
It's a
right?
full cross.
Point out
On your
something
globe.
lower than 40
I mean,
feet
this
above the
whole
water.
thing, it just screams, I can see too far. It's that obvious that it just baffles my mind
Anything
how you
to not
can't see
talk about
this.
the horizon, Brandon. Anything
Yes,
to
we
not
talk
talk
about the horizon. Yes, we
the
do.
horizon.
It's so obvious, Bob. It's like you're trying to convince me that blue is green or something.
Then
You're
how do you
trying to
explain
convince
the
us
missing?
that red is blue.
Whatever. Yeah.
How do you explain the missing parts of the platform then?
All right. Well,
How do you explain the fact that you can see the surface of the ocean between the two platforms when they're supposed to be hidden by your bulk curve?
Platform, you see what you're missing.
Or
So
the
you have to
horizon
explain
past the
that
second
curve of the earth.
platform.
Can I ask a question real quick?
Yeah.
To both. It sounds like this. Tell me either side if I'm summarizing this wrong. Brandon, you're opening with, it looks like we're seeing too far. Bob, you're countering with, yeah, because there's messy stuff going on. Is that basically it right there?
Brandon, I just posted the Stenoliner compression in general.
All right.
I mean,
No,
that's all I
well,
can
it's an
hear over and over.
oversimplification
You got it
of
wrong,
Don
Bob.
because this was originally meant to address his optical evidence, which he wants us to accept. But he's going to sit here and deny this.
Yeah, no, I got that counterpart that you were trying to offer. Like, here's my side, and you're like, hey, this version looks flat too. Now, but all he's responding with, Bob, is that it's messy. Is that really your only response, Bob? I'm trying to make sure I'm summarizing your side. I don't really hear much coming back.
Yeah, there's tremendous refraction, and there's still quite a bit of that platform missing, as you can clearly see in the close-up photo. So,
How much
quite
taller
frankly,
should that
we're seeing what
platform
we're
be,
supposed
Bob?
to see with that.
How
and
much
we're
taller
seeing what
should
we're
it be,
supposed to
Bob?
see with mine, which is actually measured. Mine
Listen,
is actually
proportions
measured.
are fine.
This one's not.
Yeah, the proportions are perfect, actually.
Yeah, it doesn't look that messed up to me. I mean, it's wavy because of this air turbulence.
Refraction.
Yeah, it's well, there's actually a specific name for this, and I think it is turbulence.
It's called refraction, and that's why we're seeing it. We're seeing it like that.
Say it one more time.
Is that standard diffraction,
What
Bob?
kind of-
Just
hey,
on
wait,
your
Bob,
core model,
refraction
that's
guy.
why?
No, that's extreme refraction. And you
It's
can measure
extreme.
how much refraction is actually present.
Not standard now?
Of course, it's not standard refraction. It's extreme, and you can measure how much is there by looking at the image and seeing how much of that image is missing.
Why would you say it's extreme?
That's called
Standard
backwards
extreme.
engineering.
He just told you why he just told you why it's extreme.
Yeah, I was
Because it
quite
doesn't
clear.
match his
Check out my
ball.
screen. I got I got the still line vote. If
Well,
y'all
Brandon,
check out my
it's been a
screen,
lot of fun.
if you could
Thank
share
you
me,
very much
Brandon.
for having me
Hold
by.
on, Bob.
I'm all done.
Hold
with
on,
it.
Bob. Hold on. Hold on, Bob. I got the still line at the top of the steps, and then at the bottom on my screen. If you could share my screen, Brandon.
Yeah.
It looks like he's gone.
Bob left. That was almost as bad as the bendy crane.
Dr. Bob, Black Swan Killer.
Oh yeah, destroyed. You got us.
Is a quick one, Brenda. Is a quick one, Brenda. Just because no one asked you before, in response to Sabine's, I don't know whether you've managed to watch it. I doubt you have. But if I have two glasses with water inside, one has got 2 degrees of water in there, and the other has got 2 degrees of water. I add them together, so that's 2 degrees plus 2 degrees.
What's the degree? Water is measured in liters, right?
Or Fahrenheit, temperature, the temperature of it.
Oh, okay.
Yeah, the temperature, whichever you prefer using, Fahrenheit or Celsius, degrees Celsius. Yeah.
Yeah.
So I've got 2 degrees, a glass with 2 degrees, and then another glass with 2 degrees. I put one inside the other. What do I end up with? Is it 4 degrees?
I've got an even better example for you.
Wait there, no, you're distracting. Answer the question. Is
No,
it 4 degrees or is it just still 2 degrees?
We're talking about the volume, though.
No, we're talking about 2 plus
temperature.
2.
We're
Always
talking about the
equals
temperature.
4,
2 plus 2. 2 degrees plus 2 degrees. Does that equal 4 degrees, or
That's
does it
not
still say 2 degrees?
2 degrees plus 2 degrees will always equal 4 degrees.
This is all you gotta get. I hope
Come on,
someone
Brenda.
said enough.
Wrong. That's not science. Sorry, love.
Yeah.
No, that's not true. That's not true. So the problem here is you're equivocating.
That's amazing.
You're equivocating on the premises, on the terms of the premises.
Yes, in science.
No, you are equivocating. You are equivocating.
You know, this was what she's explaining. This is the scientist's actual argument.
Yeah, I don't know what she said. But your rendition,
Brenda. What chance does anyone here have?
You've just literally said 2 degree glass putting into another 2 degree glass of water will create 4 degrees. It won't. It will still be 2 degrees. They equalize. They're the same.
I didn't.
You did. You just said 2 plus 2 equals 4. No.
I said the temperature 2 degrees plus another temperature of 2 degrees is 4 degrees. I didn't say anything about pouring.
But that's the argument, Brenda. It doesn't always mean. It doesn't always mean that 2 plus 2 equals 4.
It's false because it equivocates on the terms.
No, you just do not know.
Yes,
It's
it
a
does.
scientist's argument.
It's equivocating on addition, and it's
Rubbish.
equivocating.
Rubbish.
Yes, so pouring things together isn't addition.
Is it not?
Let's say
Addition.
I'm sure that's the full basis of alchemy, aka chemistry.
No, chemistry is not alchemy, and mathematics.
Oh,
the
come on,
word
Brenda. One come from the other.
Grim. Addition.
No, gleam, not grim.
Oh, whatever. Sorry about that.
You're a bit
apologies.
dizzy. It's all right. Spiraling people
grim,
go dizzy.
I mean, grief. How about
Gleam.
gleam.
We'll get there someday. It's all right. I know she ain't talking to me.
Addition.
She's equivocating.
You guys know each other too. What the
Yes.
fuck, Brenda?
I know.
Addition. Because I'm
Yeah,
being
we got two
constantly-
globe drunks in one night.
I'm being constantly interrupted like the second or third sentence in. So addition under the postulates of arithmetic is well defined, right? And so
No, it's not. It's
Yes,
not.
it is.
It's not. That
Yes,
is
it
the whole
is.
point. No, you need to go and watch the video, Brenda.
No,
you're
you're
embarrassing
wrong,
yourself.
because
Seriously, no, that is the
what are
point
the
of it.
piano-
It's
what are
argued.
the piano postulates? What are the piano postulates?
Seriously, go and watch the video.
What are they?
Brenda,
What are they?
Brenda, I don't know. Seriously,
Yes,
just
I
go and
know
watch
you
the
don't know.
video.
I
I
know
don't
you
know,
don't know
but
what
I
the piano
trust
postulates are.
Sabine more than I trust you. Put it that way.
Oh,
And
you didn't-
it isn't even Sabine. It's Sabine backing another scientist up. So you seriously need to go and watch it,
So
and
the
you can
error-
explain your postulates if you need to.
The error is that she's either misusing the function of addition or she's equivocating on her terms.
So,
you
Brandon,
watched
just real quick before Brenda rambles on, real quick, if on BLS Bay's new video, he shows the bendy crane. It's new, all brand new footage and everything.
Oh.
He shows the bendy crane in time lapse over a couple hours, straighten back out, but the horizon doesn't dip.
Really?
What? Blow my mind.
Ooh.
Oh,
is
what are you guys going to do if you don't have bendy cranes?
So the Black Swan,
Extreme flattening refraction.
the Black Swan argument can be easily refuted because it's logically fallacious. It commits the error of equivocation and a straw man fallacy.
Define equivocation.
It's when your terms, when you equivocate on the meaning of the terms, right?
You can't use the word in the definition, dude.
So
Try again.
Equivocation means
No, it's to do with averages, Brenda.
no, it
It's-
doesn't have anything to do. Equivocation has nothing to do with averages. It has to do when you're
It's to use
Get your
ambiguous
geometry, deal with
language
it.
to conceal the truth. Here,
equivocation.
I'll just say it. It's to use ambiguous language to conceal the truth.
Yes, that's what I said. When your terms.
What's funny is we never hear about we don't see any of their globe math pointing out how much is hidden behind the horizon because y'all lost your horizon, you lost your geometry, deal with it.
No, we haven't lost anything. So the Black Swan argument is fallacious because it equates the apparent horizon with the geometric horizon, which makes it logically fallacious, committing the fallacy of equivocation. It also commits a straw man fallacy because it is, in fact, a prediction of the globe model that the apparent horizon can be further away than the geometric horizon.
Yeah, we know it's unfalsifiable. You've set it up in such a way that there is no optical
No, it can
observation
be
that could ever
falsified.
possibly falsify the shape of the Earth. We
No,
got
you could easily falsify it.
Please do tell me how I
we
could.
falsify it. Yeah, we never get that answer of how we falsify it. You always tell us it is falsifiable, but everything that we bring up to try to falsify it, you can't.
I'll tell you how. You could
Please.
simply achieve sufficient altitude with a spacecraft and then photograph the Earth, and
Can you
show
take us?
that it is a disk instead of a sphere. And
Sure,
you
guys, you could just
falsify-
accept their pretend land nonsense long enough to build a magical craft to go to their pretend land nonsense, and then take a picture in pretend land nonsense, and then bring it back, and that'd be all falsified. No big deal.
Just trust our psychological operation from the Department of Defense, and then I'll be good. We can all go home.
So
her magical spacecraft can only her magical spacecraft can only see 4% of the Earth. They can barely see Florida and Georgia on the ISS.
So spacecraft.
I'll tell you how you prove Narnia.
Spacecraft.
Okay, I'll tell you how to prove Narnia.
Yeah, go to Narnia and take a picture, duh.
Yeah, so you got to make the exact replica of the closet that they walk through, following these very precise instructions of the exact dimensions required, and you'll find your way into Narnia, no problem. That simple, right?
Spacecraft are not actually.
You finding it?
Spacecraft are not fantasies. They are in fact regularly produced by several different companies, and they
they're super pretend.
They offer tours.
They're super pretend.
There is passenger service.
Can I get one that looks like the Millennium Falcon?
If you can pay for it.
Exactly.
Hey, you said we could falsify it by going up, basically being NASA or being allowed to go where NASA goes.
You don't have to
How
be
can we
NASA.
do it on the ground? Is there a way we can falsify your model of optics on the ground?
You could demonstrate that you could provide measurements of the flat Earth. That would be a good start.
And how would we do that?
That's up to you.
Optically.
You need to provide measurements.
Plane surveyors.
You need to provide planes, geodetic surveyors routinely observe spherical
Let's say
accents.
you were going to go out and do it. Just save your shit.
No,
But let's say you were going to go out and try to falsify the globe model optically. What would you do?
Well, the way you would falsify any model is you may take a prediction of that model and show that it can't be
Your
satisfied.
model predicts every result. That's my point.
No, it doesn't.
Yes, it does. There's nothing I can show you that your model can't predict somehow. You have light bending every which fucking way you need it to.
Brandon, let me bring it full circle. Okay. Here we go, Brenda. Okay, you said that additions are not the same. So if we go speed of light and say, if I can get something up to the 75% of speed of light, and then I can fire a torch at 75% of speed of light, will the light be coming out of my torch at 1.5 times the speed of light?
No, of course not. The speed of light is a constant.
Oh. So then, I mean, in that case, it's obviously 0.75 plus 0.75 isn't 1.5.
Yeah, that's you're misusing addition again.
Misusing. You're the one misusing it, obviously.
Okay. Sorry.
Yes, of course, Clean. It's your fault that
Speed of
didn't
light
work.
is a physical constant. The speed of light is a physical constant.
And what is a constant? Is it an average?
So, no, a constant is
It's
something.
it's not an average taken by laboratories all around
No,
the world.
it's not. It's
You did say 2 plus
Okay.
2 equals 4, Brenda, in all worlds earlier.
yes,
So I
yes, it
assume
does.
0.75 plus 0.75 has the same equivalence, or is it different
Yes.
if you start to incorporate decimals?
Right. So 0.75 plus 0.75 is equal to
It's different for decimals.
1.5, right? It is equal to 1.5. However, that's in math.
In all worlds, Brenda, is that like 2 plus 2?
In mathematical.
No, in all worlds, like
Yes.
you said earlier.
No,
We're
but
sticking
in
with
the
the realm
physical
you defined earlier.
Oh.
In all worlds, then.
Wait. He just made the distinction. It's true in math, but in the physical world, it's not necessarily true. So in math, something can be true and work and be fine, while in the physical world, it can be literally untrue and not work.
Right. So you're misusing addition.
Therefore, science
because,
is not
again,
reality, right, Brandon?
Again, addition is well defined in the Peano axioms, which is
So just because you can make
arithmetic is
something
not.
work in math doesn't mean it works in reality. Great.
Well, absolutely. There's plenty of abstract math that has no connection to reality.
Yeah.
Hello? That doesn't refute
Brenda,
reality.
could you just Brenda, just for clarity, could you just explain the contradiction in things you've said and why it's valid? Just to help us along a little bit.
Explain what contradiction?
Well, the 2 plus 2 is definitely 4 in all worlds.
Yes.
0.75 plus 0.75 is not 1.5.
Oh, it is
In
1.75 plus 1 point.
No, Brenda. This wasn't my maths, so let's just bring Glean back in to clarify the question of what this bit of maths, and then you can clarify why it's different and in which worlds it is different.
Yeah, so I've got a
Please.
velocity of light 0.75, so 75% the speed of light, so it's not at the speed of light. So I'm traveling at that, and then I fire a torch out, firing photons out 75% or the speed of light, let's say. Would it be 0.75 plus the speed of light?
That would be the addition, yeah.
It's not, though.
Yeah, the fact that a mathematical equation gives you a certain result doesn't mean it necessarily applies to the real world. There's a difference between the pure mathematics and applied mathematics. The application to the real world could never happen in this case because you can't go faster than the speed of light.
Okay, so
Mic check. Hello. Sorry, can anyone hear me?
relativity's postulate.
Yes, Brian. Hey.
Still reigns, yeah?
Repeat that, Gleam. I think I stepped on you when I was
Well,
flying
it's
by.
relativity's postulates. The one is basically that all physics must remain the same in all frames of reference, and the speed of light must remain constant in all frames of reference.
The speed of light is a constant, and then there's the
Yeah,
equivalence
but it's
principle.
the addition. It's the additional velocities. What you're not getting.
The fact that you can add numbers together doesn't imply that you're going to be able to go faster than
But
light.
it's not true. You was just making out earlier that 2 + 2 = 4 in all
Yes,
instances.
it does. Yes, yes.
Not in
And if
reality, then just in maths.
No, it would still be if you multiply or add.
So does that apply to reality?
So I don't get to complete my sentences.
Sorry,
If
it's reality.
No, so the claim is that 1 + 0.75 would equal 1.75 the speed of the speed of light, right? That sentence, that equation is valid. It doesn't mean that it applies to our physical world.
Huh?
Okay, so that's what I'm not getting. You originally said and implied that 2 + 2 = 4 in worlds. Real
Yes,
world,
all possible.
fake world, mathematic world, abstract, whatever.
I explained.
Yeah,
I
and
explained
now you're
that this was-
saying, I don't know, it's kind of like a circle
Yeah,
loop.
I explained that was part
I hear
of
you, Brenda.
modal logic. So
2 + 2 is generic.
No, Brenda,
so
Brenda,
logic,
Brenda.
logic I'm talking
Brenda,
possible world
Brenda.
is a modal logic term.
Just so we can move on, Brenda. This was the contradiction that we've all heard, and this is why it's been brought up by multiple people. So it'd be easier if you just admitted that maybe the first statement or the second statement is wrong or false, which one. But to go on waffle where you're not standing by either of your own statements, which are in contradiction, it is wasting
They're not in
everyone's time, isn't it?
They're not in contradiction.
Explain why. Then explain why, then, Brenda.
I
please,
did
because
explain.
I'd
I
love
did
to hear
explain.
that.
Abstract.
Well, not very well for people to understand.
Right. So
could you try
abstract.
again?
So abstract mathematics does not necessarily apply to the real world. That's applied mathematics.
Is that all worlds or some worlds?
It means logically possible.
If we're talking worlds, then, so in number of worlds, which is your first
is-
statement, so we're relating to everything
The
in
worlds-
all worlds.
The
Are
world.
you differentiating within your all worlds whether there's a subdivision of
Worlds-
all worlds?
Right. The worlds in modal logic refer to it's possible worlds. That's what
Not
modal
all
logic
worlds, not worlds. You didn't say worlds in modal logic. You said all
logically
worlds.
possible worlds. That's what
No,
modal
you
logic
said
is
all
about.
worlds, Brenda.
Modal-
And you've
Right.
got to move. You've got to move forward from the point of all worlds, not all modal worlds. That's not what you first said. So all
So-
worlds. Move from there.
So in this world, 0.7.
No, not this world. All worlds.
In this world, 0.75.
No, all worlds, Brenda. They're your words. Stop changing
Just
your
have to
words,
allow
Brenda.
me to complete my sentences. If you don't understand and you
No.
don't let me complete
All
the
worlds.
sentences, you'll never understand. 0.75.
I'll give it a
plus
go.
one-
Let's give it a go.
Yeah,
Let's give it a go, Brenda.
0.75.
Off you go.
The
Go on.
equation the equation 0.75 plus 1 equals 1.75 in this world. That doesn't mean that you can travel faster than the speed of light.
So it's not true in all worlds.
No, it is true. 0.75 plus 1 is 1.
So what Gleam said is true then? You can travel faster than the speed of light?
No, it's not true.
Gleam, help me. I'm lost because...
The fact
I was lost as soon as it's flipping.
Could I say something?
The fact that you can add two numbers doesn't mean that you can travel faster than light.
So it's not
2
true
plus
in
2
all
is
worlds.
generic, guys. Leave her alone.
That's how I understood it.
It's really simple. The fact that you can perform addition doesn't mean you can travel faster than light.
Yes,
So
let
it's
me-
not
let me
true in all
try-
worlds,
Let
then,
me
Brendan.
try it in another word.
Yeah,
You're assuming
that's exactly
that
right.
to add,
Can I say
to
something?
add to speed,
She didn't
you
say
need
it
to
was
use...
true in all worlds when the light.
He did that on the
Faraday
first
said
statement.
Hold on, guys.
It was
Hold on.
generic.
Hello.
Brendan,
Can I say
clarify,
something?
can you? Because otherwise this will turn
John.
into a silliness.
So
Just
you
clarify where we're
assume,
at.
that to add two speeds, you need to use the pure mathematical sign.
No,
plus.
we didn't assume
That's
that.
what you
Brendan made
assume.
the positive
That's
statement
what you
that 2
assume.
plus
You
2
say I have
is
1
4 in all
and
worlds.
0.75 and 1,
Waste of
and I
time.
must use the plus mathematical sign. That's what you
Brenda
say.
made the positive statement that 2 plus 2 is 4 in all worlds. She's now saying that's not strictly true because of blah.
No, it's not strictly true. It's,
she's not saying that. Let's stick with
it's
what
not-
Brenda's
no,
saying.
you apply it.
Mikey,
You apply
if we
to
get into the
something
ramble that you
wrongly.
believe, we'll go off into absolutely
No,
ridiculous.
you
So let's just stick
assume
with what
that if
Brenda's
you have
saying.
1,
I know
one
it'd be nice. You're a
of
white
one-
knight and you're
one
a
of
brave
something,
man.
another one
Put on
of
your
something,
armor.
that the
off you
pure
go.
mathematical sign of plus
Yeah, let's stick with
is
Brenda.
what you need to apply to it.
With
That's
Brenda.
what you're assuming.
Let's stick with the claim that's at hand instead of you're adding something new in, because that's pointless. We'll never clarify anything.
Well,
Is
maybe I should talk all over you since
Oh,
you
is-
talk all
is 2
over
plus
everyone.
2?
No, yes, why
Is
not?
2 plus 2
Why,
4?
why should it be explicit for you?
I'll tell you what,
Okay, so
mate.
are you
You're
done
a
No,
clearing
shut
that
up.
up for
We're not
Could I
Brenda?
add
Or...
2 things into this conversation, please? If people don't
Yeah,
mind.
go on,
because I'll
Brian.
just commit for a
Is
mo-
2 plus 2
Sorry,
4
thank
in
you,
all
Adam.
worlds, Brian?
Oh, absolutely. I don't disagree with
Yeah,
that. It would be
absolutely.
impossible to disagree with.
Right. I
Um,
totally agree with
I have
Brian.
two
I
things to
totally
say.
agree with Brian.
I have two things to say, because I'm going to come in for a moment. Hello, everybody. Number one, I listened to the stream there a few minutes ago, and I listened to Bob talk about the Black Swan photograph. He debunks his own claim, because he even says himself, he says, the horizon is a false horizon. That's the point, Bob. It's meant to be. It's an apparent horizon, not geometric. That's the point. That's our argument. So he destroys his own argument with that straight away. So that's his argument out the window. Number
That's
two,
false.
would Brenda? No, it's not false. 100%. Don't think false is the horizon. Would Brenda please provide for everyone or any of the other ballers anywhere in the world, right? The measurement for the one-way speed of light. Thank you. See you later.
Oh, there is no measurement for the one-way speed of light. There you go. There's
There
no
is
measurement
attempts.
for it. It's not possible to measure the one-way speed of light.
There is attempts though.
There's not possible.
There is attempts. Look up the one-way speed of light on Wiki. It's
Yeah,
never
there's-
been
it's-
achieved, but it's been
Right.
attempted.
Yes, of course it's been attempted, but it's not possible. Right. And so the fact that you can
Did
add
science confirm it was not possible for dead certain? Is that like 100% fact?
it's not possible because the speed of light is a constant.
As
Are you
far as
sure?
we know, there's no way to do it. As far as we know today.
Yeah, but it's not a solid 100% impossibility, is it?
That's because science is inductive, and we could be wrong. It's possible that there are things that
So
can
don't
travel
say it's impossible, please, Brenda. You keep on using
Brenda,
wrong words.
has anybody measured Gleam on his spaceship with his torch and confirmed that light doesn't do that? Is that been definitely ruled out? That Gleam on a spaceship with a torch doesn't break 2, or does break 2 plus 2 equals 4?
Those are two different things. The equation.
And gleam, yes, I know.
The equation. The equation.
I said gleam on a spaceship.
Yeah, the equation 2 + 2 = 4 is true in this world, in all possible worlds. That doesn't mean that you can travel faster than light. I don't know how to say
So
it any
other
differently.
than gleam on a spaceship, it's true.
What?
With a torch, obviously, with a torch.
Yeah, that's relativity. Relativity predicts what would happen in that case.
So I'm nearly there then. I think I've got the full Brendinian understanding. Yeah. So 2 + 2 is true in all worlds unless gleams on a spaceship with a torch.
No, it's true even in the world with gleam on a spaceship with a torch.
Explain why, because now I thought I had it and now you've ruined it. So why is it true for gleam on a spaceship with a torch?
Oh, the equation, the sentence 2 + 2 = 4 is true, even with
Oh, so no, because you're descending into retard here, Brenda. Come on, you've got to give yourself more credit than that. Come on, a better answer's you're worthy of a better answer than that.
What's wrong with that one?
Take a breath, and have a think.
What's wrong with it?
Better than that. You better than that, Brenda.
No, but what's wrong with it?
To the sentence on the spaceship's still true. That's just really weak, Brenda, isn't it? It shows you probably lost the argument, really, doesn't it?
No, that's what.
Come
That's what
on.
mathematics is. Mathematics is a language.
Mathematics is not sentences that are still
Yes, it
true,
is.
which hold
Yes,
true
it
in
is.
English within the English language. Would that sentence be true in Spanish if it was written in the English language?
Propositions are sentences.
Brenda, would it be true in Spanish if it was written in the English language?
Yes, it would be true in any language.
It wouldn't make sense, would it, in Spanish?
2 + 2 = 4 in any language.
No, we were using language, not mathematics.
Mathematics is a language.
The language of mathematics, you can get that linguistic, but that wasn't what you were saying. You said the sentence of, didn't you?
Yes, 2 + 2 = 4.
So you've distracted away from that, as I said, because you've lost the argument. So probably done now. 'Cause this is just turning into ridiculous.
Adam, are you saying that 2 + 2 = 4 is not true in some languages?
So 2 + 2 = 4 can be.
Yeah, I'm not shy. Just answer the question. Don't be a coward.
Who is it?
Come on.
Who is it then?
Are you saying 2 + 2 = 4 is not true in some languages, Adam? Yes or no? Come on, answer the question.
Who am I talking to?
Chikey, she said 2 degrees plus 2 degrees.
Yeah, I'm not
She
shy.
said a 2-degree glass of water.
Come on.
Chikey,
the first question
she said
was
a 2-degree glass of water mixed with another 2-degree glass of water makes a 4-degree glass of water. We're talking to a fucking retard.
Mixing is not arithmetic. Addition is well defined. Mixing is not arithmetic.
Yeah, Brian, I'm not
like mixing cocktails. Or
our point precisely.
Cocktail mixing isn't. Mixology is not arithmetic. You're correct.
Right. Therefore,
great point.
Therefore,
really on topic.
Therefore, the objection.
I like it. Keep going.
Yeah, it's a malformed objection.
Yes.
What yours was? Yes, I totally agree because
mine
mixing
was
cocktails
not.
has nothing to do with what we were talking about.
If you're accurately representing Sabine Hassenfelder, then she has a malformed objection.
Whoa! No, we were talking about you and your statements, Brenda, not Sabine. We already defined, both me and you early on, that she was absolutely mad as a box of frogs, didn't we?
No, I never
both
said
agreed
that.
on that.
I never said that. You're gaslighting.
We were close on the definition.
No,
well, at least
you're gaslighting. You're gaslighting.
Brenda,
You
I'm
never
happy
said
from
that.
my point of view. I'm happy.
No, you're gaslighting. I never said that. I never said you're
No,
gaslighting.
I'm not. I'm just bullshitting like you are, trying to stay away from the point of the topic. Because you've already lost it, haven't you?
No, you're gaslighting.
I'm done playing.
Once again, you said a 2-degree glass of water plus a 2-degree glass of water equals a 4-degree glass of water. That makes you a retard.
Yes, 2 plus 2 degrees plus 2 degrees is 4 degrees. However, mixing two substances together is not addition.
Then you shouldn't have said 4, should you? But you're
one
a hardhead,
substance.
stubborn. You're the reason I
adding-
haven't even deep flat earth a chance.
Let me read a couple of super chats real quick. I don't know what that noise was that came out. James Richard, $5. Brenda, you said 2 divided by 2 equals 4. I think you meant to do a plus sign. James, 2 plus 2 equals 4. Then went on to say math proves things. Math proves math, like 2 plus 2 equals 4, not things. Yeah, I couldn't make heads or tail of what the hell Brenda was trying to say there. It was very wish-washy. And then James, $5 again. If the curve of the earth is obscuring something 47 feet off the water, you should not see the surface of water beyond it. Makes logical sense to me. I think it even might make geometric sense. But I don't know. I guess we can pick and choose which optical observations we want to say reflect reality. So at least according to Bob. Thank you very much, James. Appreciate it, man.
Okay, let's make it easier. Ice. So I've got half a glass of ice. Take the glass away. Both glasses. I've got 2 half of ice, and then I put it together. Okay. Each of the ice blocks are 0 degrees.
So if I have a
0 plus or 1 degree, let's say, because they're warming up. So 1 degree plus 1 degree equals when they're put together.
Yeah, so?
But that would, yeah, I don't get you.
Is that addition? That's not addition.
The whole net body
That's not
is
addition.
1 degree.
That's not addition. Addition is a counting operation.
Yeah, but I'm counting.
No, you're not. You're
1 half
the depth of
to another half to make a whole.
Right. So you're mixing. You're not counting.
Okay, so if I go, there is a northern hemisphere and there is a southern hemisphere. How many hemispheres is there?
2.
Is that mixing? Because they are mixing?
No, that's counting.
But they're mixing. It's the same as... Yeah, they are.
No, they're not. You don't find the southern hemisphere and the northern hemisphere, do you?
Yeah, you do.
No, you don't.
They mix. They mix.
No, they don't. No, they don't.
They definitely mix. They definitely mix. You are not telling me that there is a dead straight 100% line.
Everything below the equator is the southern hemisphere.
Yeah, but the equator isn't a dead straight line. Come on.
Yes, it is. It's a circle. It's a great circle.
Okay. So anyway, either way, Sabine, I side with Sabine and Einstein because Einstein says 1 plus 1 equals 1. That is essentially it.
Yes.
C plus C.
You'll never get a concession out of a mule. You're arguing with a mule.
Einstein says that 1 plus 1 equals 2.
No, Einstein says 1 plus 1 equals 1. Because no matter how much you additional velocities at the speed of light, it will always remain the same.
Wait, Einstein
doesn't say that. You're just not understanding relativity.
Is light in this world, as in all worlds?
Yes, and it always travels at the speed of light.
Bugger, Brenda. Bugger. Eh?
Well, you're not.
So let's go back to what you said at the start. That 2 plus 2 is equal to 4 in all worlds.
Yes.
But you've just made the clear statement that that's not true. So how are you going to rectify the clear contradiction between your initial statement an hour and a half or so or more ago,
right,
and your now admission with regards to agreeing with Einstein that 1 plus 1 is always equals 1 in that world, in that world.
That's not what Einstein
that world
says.
being part of.
If you look in the chat, that's what Sabine says. Einstein says.
Nowhere does Einstein ever say that 1 plus 1 equals 1.
He does in his second postulate.
No, that's the interpretation of someone.
The additional velocities of the speed of light will always equal the speed of light.
This is some woman saying it on YouTube.
It's not some woman, it's a qualified physicist, you dickhead.
Right, so someone says it on YouTube, therefore it's true. I forgot, sorry.
She's a physicist and a well-known physicist. What are you on about?
Einstein.
Are you then saying that when it goes on YouTube, the information becomes false?
Right, and what's the context of this so-called quote?
That 2 + 2 doesn't always equal 4.
Yeah,
which is
Really?
another
I don't
physicist's
see a 2
argument.
in there.
Yeah, will you just actually load it up then, Ed, and look at it, or get your glasses on? Because it literally says it in the title of the video.
Don't know the context,
That's
then.
the name of the video.
You just saw something in the subtitles.
It's the name of the video,
This
you idiot.
surely goes with my point. I have to post this.
You
This
have
must
no
be
point,
correct.
Ed. You're just saying
Don't
shit.
have to do any research. Just go ahead.
Not at all. So you are telling me that if you add the velocities of light, you will get something other than the velocity of light.
Are you going to give us the context or not?
The context is the second postulate of relativity. The speed of light is always the same in all reference frames. You cannot add one speed of light plus another speed of light to get two speed of lights. It's only one speed of light, so it's 1 + 1 = 1.
She's equivocating.
Oh.
Uh-huh.
Either way, Einstein was a much smarter mathematician than you.
That's genius. Just to clarify then, so instead of ballers to keep your faith, don't listen to Einstein and Sabine, yeah? It's Brenda and, is it Ed, that know the true reality of the ball dimensions.
Do you understand what an analogy is, Adam?
Because 2 + 2 is equal to 4 in all words. That's not my claim, that's Brenda's. Don't get upset, Ed. Don't get raggy, Ed. That's Brenda's claim, not mine. Don't get attack Brenda.
So is your claim then that 2 + 2 = 4 is not true in some languages? You never answered that question, Adam. Stop hiding.
In languages?
So just answer the question. Is 2 + 2 = 4 not true in some languages?
Unless they understood English, if it was written in a language.
Is
in
it
maths,
true?
if they understood,
Is it not true in some languages, Adam?
Symbols, then yes.
Just a simple yes or no. We don't need your stories. Come on. Be honest for once. Answer the question.
It'd be written in mathematically.
Yeah, he can't
You're not answering the question, Adam. We don't need your stories.
I just did. You talked through it.
No, we don't need your stories, buddy. Just answer the question.
It's not a story. It was an explanation.
No, it's a bunch of horseshit. So, does 2 + 2 = 4? Is that not true in some languages, Adam? Simple yes or no.
That's what. So stop talking.
Simple yes or no, Adam. We don't need another story. Come on.
Stop talking.
So you're hiding again, aren't you?
Ooh.
That's right. Run away.
Hey. I understand. I take it you've lost. You too.
Well, you're not answering the question, so you're hiding. You're being
I did. Every time I spoke, you overspoke me. Actually, I gave a full.
No, you're just horseshitting around it. So is it yes or no?
Your show with this
2 + 2 = 4. True or false in some languages?
Absolutely. Demolition of the ball.
So, are you going to answer or not?
He's answering. Shut up, Ed.
So, do temperatures add by the rule 2 + 2 = 4?
No, they don't, Brenda.
But before, the people here were trying to tell me they do.
No, we weren't.
Why did the mule say 4? Why did the mule say 4?
It doesn't work out like that,
Right,
Brenda.
so
You was the one
does-
saying it was absolute, and we were saying no, it isn't. Not all the time.
Why does Sabine?
No, they tell you they don't aid by the rule 2 + 2
You are getting
=
excited
4.
and just flipping it on us as
Are
if
you
that was
dumb,
our argument. You're a twat.
So why does Sabine say?
So, Brenda, if I move 2 feet to the side and then I move 2 feet back to the other side, so I move 2 feet to the right and then 2 feet to the left, how far have I gone?
4 feet.
4 feet.
From where?
The length of your trip is 4 feet.
You moved a total of 4 feet.
But I haven't.
Aaron, you're arguing with a mule.
But I actually haven't moved.
Attack mules right now, bro.
Are you saying
Let's move on, please.
So that's the equivocation. That's the equivocation. Face said, if I move 2 feet
Oh,
to
let
the right
Rakia
and
get
2
it.
feet
Hey.
to the left, and then he says, I haven't moved, but you have moved.
No,
You're
but I
right.
haven't.
You're right, Brandon. You're
Yeah,
right, Brandon.
Okay,
she
You're
got
right.
him.
Wait, I want to hear what Rocky has to say real quick.
Yeah, for everyone who's let Brenda and other Globers in here like her take y'all on the 2+2 math dance, I'm ashamed of y'all.
Thank you. I agree.
Well, the dance was given from the flat side, not the globe side.
Oh, come on.
It's worse than the drunken Bob dance before that. I love drunk Bob, dude. Gives us sound bites every time.
Are we done exploring the depths of Brender's psychosis? And
Well, you
we can
want to
move on
talk about
something
your
more useful?
Yeah, you wanted to bring something up, didn't you, Bob?
Yep, indeedy.
Let's see if we can do something constructive.
Yeah, please.
Oh, goody. All right, let me go ahead and get back over to the computer.
All right.
I'm
Here
surprised
we go.
Brenda ain't arguing for the flat Earth by now.
So, I'm going to share my screen here, and we can take a look-see. What's up? Okay. Just going to share my whole screen. Whatever.
You'll
You guys
always
see
live in the
important
shoe.
stuff. Don't use it against me. All right. So, do you guys see what's on my screen now? There should be A, B, C, and D, and some lines.
Yeah. Is there any way you can zoom in a little bit? I can't zoom in on it on my side because it's on Discord. It's a little
View.
small.
Zoom in. Oh, whoa.
Yeah,
there we go. Okay.
Perfect.
All right. Okay. So, over the weekend, I had a couple discussions with the one known as Dr. Bob, who was on here earlier.
The drunk guy?
And it seemed like, what's that?
Nothing. Go ahead.
Oh, it seemed like he was indicating to me that the argument he's heard from the flat Earth side on this whole angular resolution business had to do with essentially this, okay? That if there was like a building, and I'll go ahead and put something up there to represent a building, like if there was a building over here that you're looking at, and here's the observer right here, okay? Over here by A. Okay, he's saying that the argument that he's heard apparently was that as you move this observer height down, that this angle will somehow change, and then that's how things are hidden from the bottom up. Is that an argument that flat earthers are making?
Nathan Oakley makes that claim, yes.
Okay, anybody else, or is it just him?
There is a compression element at the bottom, yes.
Yeah.
Oh, but that's not what I'm
Quantify
talking
it.
about. I'm talking about just if you look at this
No,
particular
the
picture
foreshortening
and you
bit,
were to drag this down, are you under the impression that the angle would have to change and that somehow this would be less visible from the bottom up?
Do you mean orthographically or optically, in terms of the way you would interpret an optical thing?
Well, okay, so this is just what was essentially this. I didn't grab the exact picture. I tried to reconstruct it, but this is essentially what was given to me as the flat Earth argument, and this is not what I consider the argument in general to be. Okay, and I told
don't
him what
understand
I
the
thought
argument.
it was.
That's what I'm saying. Is this an optical representation with regards to optical compression that is documented? We all understand.
It's an
or is it
illustration.
just is it a description of the physicality in orthographic view?
It's an illustration, dude.
It's just a picture in paint that I put together to attempt to represent what they were talking about. Imagine if you are, I guess, from the side looking at a person over on the left, and his eyesight goes out like this and can see the whole building. Are flat earthers making the argument that as you move this closer to the ground, this angle changes somehow, the BAC, and that is what makes...
Then the answer is no, because as you described, it's an orthographic representation of both the viewer and the object in view.
All right, what's wrong with
so
that?
No, it wouldn't.
What's wrong with an orthographic projection?
I'm agreeing with him. No, it wouldn't change because it's an orthographic projection which includes the viewer and the thing supposedly viewed from the optics. The optics are at A. The picture you take is taken from A. This is a orthographic view, which includes the viewer and the object that would be viewed from the camera A.
Yeah,
And,
so what?
Stop dumbing it down. Stop dumbing things down. It was a good conversation till your dumbass
Yeah, let's move it forward. He's not.
Can't even comprehend that. It's pathetic.
He was agreeing.
Let me ask this: if I were to, just right now, don't worry about the other discussion or whatever. Just right now, looking at this picture, if I were to say to you, if I drag this position downward to D and make it perfectly level with this line here, DC, that will not change the angle, and that by itself will not affect what you're seeing of the building.
That is
incorrect.
Correct.
No,
that is
it
correct.
will.
Okay.
No,
You think that's
let me-
incorrect?
It is
Okay.
absolutely
I'll let
correct.
Brenda talk a load of shit, and then I'll address it after. Go, Brenda.
Oh, okay.
Give some
Okay.
cock
The
waffle.
angle BAC will always be the same as long as you move it vertically up and down.
I agree with that.
Incorrect. No, you can take it so far
that's
and it
just
will
geometry.
foreshorten too much.
That's just geometry. You can't refute that. That's something you could actually prove.
Incorrect. You can put it 20
Go ahead.
times higher up. You can put it 20 times higher up and the angle will become smaller because it will foreshorten.
While you below and above below the top and above the bottom. While you in that range.
I love the way, Gleam, right? They've lost even before the main point.
I got what you said. I got
weak
what you
point,
said.
and you slapped them hard before shortening.
So you're saying if I drug this, if I was able to drag this box, which I don't think I can do it in paint like this, if I was able to drag this box with these lines with it and drag it down here, that it would necessarily change the angle BAC? That's your argument?
Yes, it would.
It would change it.
Yes, it would.
Wouldn't.
And I can,
Okay.
Yes, it
Okay.
would. Gee, I can show. I can do the diagram, and I can drag it if you like. In my
And this is not the me trying to make a primary point with this picture. This is what was essentially given to me as the flat Earth argument, that moving this down would change the angle, and that would somehow affect what you can see of the building. I didn't think that was an argument that was that's not the argument I thought was being made with angular resolution. I can explain what I thought was being made as an argument for angular resolution.
There is no standard flat Earth argument for.
Okay.
He said
so. This could just be what the Dr. Bob guy has heard from the people he's
basic
talked
lack
to.
of understanding of angular resolution. Respectfully, whoever's told you this doesn't understand the points that have been made up until this point. They've just got some half-baked non-understanding and led you down a goose chase, mate.
That's what I thought. What I said to this was that's not the argument that I think they're making at all. And then I proceeded to try to explain to him the argument that I would make about this situation and why it would seem to disappear from the bottom up. I made a separate argument that had nothing to do with where this person was situated between A and D.
Do you know what? Go ahead.
There's a complete difference between the size of that angle of ABC and whether or not things disappear from the bottom up, or there's whatever the other point you were making. Those two things are completely separate. Angular resolution, I don't think Adam even understands what that is, because he's talking about the angular resolution in terms of the device that's making the op. We're talking about the angle. We're not talking about angular resolution. We're talking about whether the angle ABC changes as a result of moving A up and down. So I've got a demonstration here, if you can look at my screen.
Okay, all right.
So here we have, I've drawn this thing here. Well, where did you have A? Sorry, where did you put, was A, remind me where you had A? Was it the top?
I had A on the left side of my screen.
So A was here. Where was B?
And then B is up and to the right a little bit. C is down to the right.
As you're having difficulty, let me just go and what had A, B, right? Okay, there you are, I can see it now. Okay, you had A, B, and C. Okay, and then you had along here, you had there's presumed some sort of some.
I'll stop sharing for right now while you do your thing, and then I'll come back. Okay, because I still had more stuff to go over. But
okay, I'll go and take over. Right. So here we have your little triangle. So here we have A as the eye of the observer. Let's say I can put a little.
Anyway, you
let's
can
match
zoom
the
a little
eye
bit,
there.
Rumpus. Can
Right.
Can you zoom it in a little bit? It's really small for
Right. Sorry.
the audience. No, that's all right. Thank you.
Okay. Right. So here we have So here we have the observer. I put in as a star. I could go and put something more focus in. Anyway, so as I move this A up and down, and you can imagine if you went to an extreme to make the point, you can see that it's varying. And I'm making the point by going down further, just so it's very simple that the angle is changing. It's just simple. Job must change. Okay, but that's got nothing to do with the other point that you were. I can't remember the phrase you were using. How much of the of losing bit to the bottom or anything? That's not affected by
Right. Okay.
Actually, I mean, if you can imagine you went way down here, you can see that what you will see across your line of vision will now be your line of vision would now be what you would see would be this across here. That would be what you would see as you would now see that in this end would be closer.
Foreshortened.
Yes, that's correct. Actually.
Okay.
So that you would have the point C closer to your eye, but point B further away, and obviously you'd then have a perspective effect, and actually C would appear whatever. Imagine there's a feature on C. Imagine there's an ant at C, another ant at B. The ant at C would obviously appear slightly larger than the ant at B because the ant at B is further away. But I don't think this is the argument they're using. They don't understand this. Whoever is it, Bob Dole, whoever's speaking, they have obviously no understanding of what I've just described. Because they're starting to use other arguments about angular. I mean, we had Adam just speaking now about angular resolution. This has got nothing to do with angular resolution. He doesn't understand what that is, I think. So they may have been giving you other arguments. I don't think the argument they're giving to you has nothing to do with the angular resolution issue, even if they have made the argument that the angle changes, because as I've demonstrated, it indeed does do that. Okay,
Shall I show you what they mean, Rumpus? Grab your line and pull it right the way down to the bottom of the paper, and then move it more over to the right.
Hold on, let me just.
And that's their argument, and it's so simple to understand it.
Okay. So what do you want me to do with this point?
Grab it, bring it to the right over to like mirror. Yeah, a bit more, maybe, bit more. Yeah. Okay. Right now, that's the floor.
That's the floor. What do you mean? We're side on.
Yeah.
Below the floor.
That's not.
No, wait there.
Hang on.
Hang on.
I mean, that's the floor.
Wow, hang on.
You're lying
Stop
already,
having a
Dave.
panic. Just
You're
stop.
lying.
Stop having a panic attack. All you have to do is rotate it 90 degrees, for
Why
God's
are we
sake.
rotating anything? What are you talking about? We're just
Because that's the argument. If you didn't want to know the argument, that's okay.
Okay, you're just talking gibberish. There's no point talking.
No, I can show you. I can show
Here's
you
the
in
observer.
Photoshop.
Here's the observer, and I've made him go underground. I mean,
Yeah,
you could
I
imagine.
know.
Right now, the
if you
angle's
like,
underground.
You can imagine that this
I
was
know.
on top of a mountain.
I know.
But if you
And I
prefer-
just flipped it and treated that as the ground.
You could have this as a mount. This being on a mountain here, and we could draw in a quick mountain here. So that would be.
Wouldn't the ground be your lowest angle? How could you get below it?
By digging.
You can't. No. I think he was just demonstrating something.
Yeah, I'm demonstrating a principle. I moved it more just to make the point so it was absolutely clear that the angle was changing. I did so by exaggerating how much I moved, but you should be able to cope with the fact, well, if it's going to get to this smaller angle down here, then it must gradually change from here to here to here, getting bigger and bigger and bigger. That's the point I'm trying to make by going in ridiculous things. But the point is, if
that
you
actually
change
makes sense.
this,
So
you
I
will
thought-
change the angle.
I thought it wouldn't change between A and D, and actually, I think you're right. It seems like it would change, just not necessarily harshly,
No,
depending
it
on how far you
wouldn't
move it. If you only
change
move it a little
between-
bit, it wouldn't change that
Wouldn't
significantly,
change.
but it would change.
It wouldn't change between between B and C. As long as you below B and above C, or at that point, it will not change.
Can you say that again, Chike? I didn't understand what you said there.
I said, don't put it below C or above B.
It doesn't
and will
matter.
not change.
I just did that to exaggerate the point. The angle is
No,
changed
he
when I go to
said-
here. The angle changes when I go to there, or when I go to there, or when I go to there. It's changing all the time. Every point on here changes the angle.
So it seems like there's
Chike,
contention.
you're wrong,
Rumpus,
Chike.
it seems like there's
Rumpus is
contention
exactly
about
right.
that.
What's the angle there?
Well, that will be. Well, I'd have to go and calculate it.
He'll need to check
But you can
the vertical
You should be able to see
placement.
the principle, Chike. I don't quite understand why you haven't.
Can I show you what I mean, though,
Hold on, let
Rumpus?
Chike finish his point. Let Chike finish his point.
Yeah. What's the angle there?
Well, I could if you want me to calculate. Do you want me to calculate?
Yes, calculate it. Calculate it halfway between A and B, and 5 times the distance AB.
Okay, then.
Doesn't
right.
matter.
Okay, here we go. Then.
Make sure
Oh,
you
yeah,
check your
this thing.
vertical
This thing
coordinates.
is how many pixels. Okay, if you really want, I don't know. Are you saying you're disputing what I've said? I mean, this is incredible. That's what you're doing.
He is disputing it.
C.
Right.
I think he's saying that if you don't go above B and don't go below C, that the angle remains the same. I think that's what he's trying to say.
No, because there's always a distance
Completely
change.
and utterly wrong.
It's only at the middle that you only
thing.
get a perfect.
Right, so I can do the calculation
He
for
has
you.
a basic
so here,
misunderstanding of triangles.
yes. So
Yes.
did you
Yeah,
not
okay.
understand it? I'm surprised at you, Chike.
Okay.
You're more intelligent than this.
Choose numbers, Rumpus.
Yeah, hold on. I'm about to do that. I was just getting the units here. Right. So this is, this here is, what was that? The height of that is 206 pixels. Let's make it a bit easier. Let's make it 200.
See, I agreed that it wouldn't change, but I'm changing that idea now. I think you're right. I think that in my mind, I was dragging it down to C, level with C, and it didn't seem like it changed, but it does, but it's
That's why I
small,
exaggerated
so
it, yeah.
Yeah.
Right, so the angle here, right, and the distance from here to, I'm now going to draw in the distance from the thing from the. Well, let's make it exact. Let's put it on the exact point.
Just use GeoBra.
Could do that. Yeah, that's a good point. I suppose I'm more familiar with this program.
Geo may not be online, bruh.
You don't know what
here we
that
go.
is.
So that distance there is. Let's have a look at what that distance is. That is 475. Let's make it. Let's make it a bit easier.
500.
Yeah, let's make it 500. Let me just change that so that we can see that. So if I make this 500 here. So if I make that.
You know what, Glebe? This makes me laugh. We had the first half of it's like Sesame Street. We had the first half brought to you with counting numbers by Brenda, and then the second half, how to add up the angles within a triangle by the proven liar.
Okay, but I do have a real
Fuck off, you little wanker. You're such a moron. You're an utter
particular
tosser,
topic.
Adam. You know nothing about science or geometry. You're a moron.
I do like the cambrendula, though.
You're utter notice how the hell you can
One
be in
dog
any
bone.
profession as stupid as you are.
Three.
Right.
Two shoes.
Proven liar. Why would you listen
You're
to
a
him?
moron, Adam.
He's
If
a
you think the
proven
fact that
liar.
I didn't talk about refraction 3 years ago and
Anything
bloody
he
Nathan
says
denied
will turn out to
refraction
be a
all
lie
the
in a
time,
few months'
and I
time.
went on and on and on about using refraction values, and Nathan disputed refraction
going
at all,
on?
and he talked about a hyena hologram because he didn't accept refraction, and I kept on
No,
going
you
on.
talked about
No,
superlumin,
Nathan,
mate.
you've
I
got to
was
use
there.
refraction. I'd said everything's refracted. I told him about 40 times.
Guys,
that
focus.
everything
Never
is refracted.
refracted the
You're a moron. Anyway, you're a moron. You're a moron. So anyway, here's the angle then. So here we do the calculation.
You never refracted the horizon, pal.
Let's do the calculation then. So the this angle we call it D in here, which will be the same as the other one. So this would be the same. So the angle for that is going to be D is going to equal arctan.
Are we really going to add up the
200.
angles in a triangle?
200. Well, apparently that's what
Who requested
This is classic.
Right, so there we go. That is what
Damn,
D is going to be.
okay.
So let's go and get that angle. I'll then do the calculation in the calculator I've got here.
I'll take that back. With respect to the horizon, you never refracted anything without the horizon. In other words, if you refracted something up, everything went up. If you refracted something down, everything went down. You never refracted the horizon without refracting everything else.
Of everything. The horizon refracts with everything else. The fact you don't understand that just makes you a moron.
Just let him keep going. This is great.
Right, so that angle is 21 point. Let me get this just absolutely right. 21.8 degrees.
21.8 degrees.
You're a twat. 8 that's 21.8 degrees. So that means the total angle of it is twice that. So
43.6.
Oops.
3.6. I'm crying.
So as you said, as Brandon said, the total angle. So that was d over 2, of course.
Question for you.
D.
Do you think there's any interesting correlation between 60-degree field of view or 60-degree cone of vision at a 90-degree parallel
right?
line
That's where I was going.
line of sight? So if you go 60 divided by 90,
right. So let's now calculate. So let's now do another calculation. Let's clone that, and then
0.666.
Yeah, you're more.
I wonder if there's any.
Right. So here is let's do another one. So let's do another one here.
Just a coincidence.
Love it.
So this
Love
time
it.
the angle is going to be. So we'll call this angle E. Here. And
That's a bit angly.
Well, but the point is, I'm going to use the coordinates here. So
No, I'm with you here, Rumpus. I'm actually backing this maths, mate.
Jolly good.
You're doing a great job.
So this angle is simply going to be this is 200. Sorry, that was 200 for the whole thing. So this is going to be.
Hold on.
That was incorrect. Sorry, it was 100 because I took half of it. Apologies there. It was
Rumpus,
100.
Rumpus, you do the math. I'll do the interview.
Don't tell me I just backed you. I backed the wrong one.
Right, so it's 11 points. So the answer was 11.3, and multiply that by 2.
What is the point?
Right, here we go. So the answer to that one is actually 22 point. Here's the final. So apologies for that. It was 20. It was half basically. Right. So there we go. That's the actual angle of D. So where D is the whole of it. So that's across both of them. Sorry.
Why are we doing
D
this?
over 2. Because apparently Chike doesn't understand this. I don't know. Yeah, this is a bit.
Globers teaching Globers or something like that. They're preparing them for war or something.
That was D over 2. So that twice the angle. So D, which is 26 point.
Brandon, while he's doing his math,
size of this thing is 22.6 degrees. So let's
go ahead and do E. I'll explain what's going on here. What we're determining is if you move what he's labeled there D2, it's actually D divided by 2. So the whole D angle, okay? If you move the origin of that point A up or down vertically but not horizontally, will the angle of BAC change?
Yeah, of course.
Okay, but there's been some disagreement on that. So he's showing that is the case.
And that angle is 21.804. So those two angles, D and E, are different. Chike, you really you amaze me that you think those.
I mean, that shows that we can.
Wait a minute. Okay.
I've got a maths issue with what's written on screen. D divided by 2 equals 21.8. D equals 22.6. That's basic maths.
I didn't update that one. Okay.
I appreciate Jackie's answer, man. That's what a humble man does. When proven wrong, that's what a humble man does.
Oh, did we get it?
Nothing wrong with. We don't always got to be right.
We watch the replay of the football.
Right, so that's 11. I'll give you the exact number. Hold on, let me just go and get the exact number.
Rumpus, we've got a request from James Mays. Shout out, James. Thank you for the $20. All lines are curved, Rumpus. Show us in your diagram.
Hold on, I'm nearly there. I'm just want to give you the final correct answer on that thing that I hadn't updated. Here we go. Right, so there we are. D over 2 is equal to that formula there, just given by because you take half the height. So this here is 100. That was the bit that I.
Honestly, bloody amateurs. It's like amateur night, isn't it? It's like amateur maths night. It's pathetic to watch.
You
how much time are you going to take up correcting yourself?
I'm not correcting myself. I've just
pathetic errors. It's ridiculous to watch.
So all your
My boy's 14
I'm
and he
sorry.
doesn't make errors
You're a
like
moron.
this.
You're a
I'm
moron.
sorry that I
couldn't
backed
do
him
this.
now.
Adam, you couldn't do this.
I tell you what, in terms of
basic
his
trigonometry.
methodology,
This is the
Yeah, he
moron
could.
who doesn't
Shut up,
understand
Randolph, he
how
could.
a
He
plane,
showed you
you
up.
can't do simple geometry in terms of
back.
how much a plane has
I
to
would have
dip to
sent
go
him
around
back.
the Earth.
He wouldn't.
And you don't understand
It's
basic
shocking.
chemistry either. So anyway, I've just
Absolutely
demonstrated
shocking.
here that the if
Basic
anybody can go and check this
is
calculation when I put on the
beyond
screen,
primary
then
level.
you will see that the
I'm
value
just
of
right.
E and B are different. So I've made
There
my
is a
point. So-
difference. All right, I'll go back to sharing my screen.
Okay, go ahead.
hold on before you do that real
Oh,
quick.
someone was making a request, weren't they? Someone wanted to.
Oh yeah.
Yeah,
Wasn't
That's it.
Rumpus,
What did Brandon ask me
Rumpus. Just real quick, it'll be quick.
Okay.
The observer, the black dot, right?
The star.
Can you just move that down and all the other lines go with it? So and they stay parallel, or can you not do that?
I can move this one relatively easily, so I could do that.
So no, just move the black one down. Screw it, the observer, towards the ground. Just move it towards the ground.
Move the star. You just want me to move the star? Okay, right.
Yeah. Now picture all those lines moving with it. The bottom angle gets cut off by the ground, whereas the top one does not. It's in the sky.
Hold on. Here we go. I
So-
can move the line. So here we go. I can move this other line. I'll make this green or red or something to indicate it's the visual thing for the observer.
Yeah, I was just gonna say that's what makes things disappear bottom up on a flat plane.
That would be.
It doesn't, because you can still see the You moron, James. There's a direct line of sight. James, for it to be obscured, there has to be something in the way. There is nothing in the way between the observer at the bottom
But we
and the
don't need to
bottom
get
of the
into that
object.
right now
Therefore,
because
it's
that wasn't
not
the point.
obscured. James, for
We'll
it to
pause.
be
We'll pause.
obscured, there has to be
We'll pause.
something in the way, and there's nothing in the way, you moron.
Well, that's technically not true, Rumpus.
We'll pause, Rumpus.
Because
Let this other guy go.
Technically not true.
Okay.
Demonstrate,
So,
please.
what he's just showing here, clearly the angle would change if you change the vertical position of the viewer. The angle would
Yes,
change.
sir. Yes, sir.
Okay.
That's the
So-
angular size, remember? That angle we've just been discussing is the angular size of the object from the point of view of the observer.
Yeah. So the closer the observer is to the ground, the less of the basketball lines he sees on the court. Thank you.
Okay. So the claim that was, I'll go back to sharing my screen. The claim that was made to me seemed to be that that angle would not change, or I mean, it's possible that maybe I misunderstood what their argument was. Of course, that's a possibility. But it sounded like what they were saying was, if you move the viewer down, what they were arguing is that is the argument that was being made to them. So this Bob guy, he was saying this is the flat Earth argument. If you move this observer down, that the angle would change, or something would change over here, causing the ground to seem to cover up the building, or something along those lines. Okay?
Bob, are you
I
talking
didn't
about
think that was the argument.
Are you talking about you said the Bob guy? Are you talking about that guy who came in here and tried to make believe that we couldn't see the surface of the ocean in between those two? That guy?
The label on his thing is Dr. Bob. I don't know if he's a doctor or not, but it says Dr. Bob.
Okay.
Oh, that spectroscopy moron.
Yeah, sure.
The guy
We'll go with
claims to
that.
be a doctor in spectroscopy, and every single piece of science he's ever said has been bollocks. And
No,
he's
I-
done several videos that demonstrate he's an absolute idiot. And everybody who's had anything to do with
Oh,
him
right.
just comes away with thinking he's
I tried to stop him.
There, dumb boy. You're in the wrong there.
We're talking about Bob the Science Guy, Rumpus.
Well, that's not to be unexpected for a proven liar, is it? That you
Oh,
get
it's
the
Dr.
wrong
John
thing.
D. Sorry, I'm getting Dr. John D.
Yeah, you got it wrong. Oh, bloody hell, a bit of humility.
All right.
Yes,
Can you guys see my screen? I'm back to that other picture we were on. Do you see that?
But you're a proven wanker, Adam, and a proven moron. That's much more serious.
I'll
lying,
admit it,
and
Rumpus.
you're
I used-
lying
I
about
used to
things that would
masturbate
make
in the
you,
past.
Coming
make
from
you
you.
a double liar and a double wanker.
But I'm
Are you an
probably not
overhead
someone
projector?
like you are
Go
right
double.
now,
Go ahead,
mate.
go ahead,
Let's be
Rumpus.
honest. Hey, I'm not creaming one in the chair as we talk to everyone else, like yourself. Hey, there'll be one out while she's chatting with the boy.
You're just gibbering, Adam. We're not
Rumpus.
interested in gibberish crap.
Shocking.
Moronic drivel. We're trying to get this in the real
Disgusting to
Are you
bring
done?
the
Are you
conversation
done?
down
Come
to a
on,
level of
Rumpus, seriously.
masturbation is filthy.
Can I ask
Rumpus.
you a question, Rumpus?
Absolute
Yeah, go
depravity, you dirtbag.
So
Summer.
you're essentially at the bare minimum at the foundation of your calculations, you're doing a rise over run, right?
Well, you can call it that if you want to. I think you don't need to get involved in something. You can just use the diagram. You don't need to complicate the terminology. You can just see what I've done on screen, and we've got a horizontal and a vertical. You don't not need to start bringing in half surveying terms into the issue to complicate and confuse the issue.
But
So no
fundamentally of the mathematics that you're presenting, at its primitive state, is a rise over run calculation.
No, it's the most primitive state. It's just simply a triangle. You can start then adding on to it to make it rise and run, but that does not completely unnecessary. And you're just trying to complicate the issue, I suspect, to try and obfuscate something.
Okay, so listen, if I just do the 100 over 500 times 57.3 or pi over 180, I will get the same number that you derived using the arctangent, right?
Well, okay, let's write down what you're saying. So I'm going to write down what you just said. So here we are. This is what Fed is saying. Fed is saying the following equation. What is it? So type it.
The Fed's here?
Word by word. Tell me letter by letter.
Rise over run.
Rise divided by run. Okay, is equal to
times.
Not equals.
You have to go.
So you don't want to
rise over run. Rise over run multiplied by pi over 180 or times 57.3.
Times 180 divided by pi.
Pi over 180.
Wow. Pi over 180. Okay. Times pi divided by 180.
You know what that bit is converting there?
Yeah, he's talking gibberish.
Yeah. No, that's converting to degrees. That's all.
Yeah, but rise over run isn't an angle, stupid flipping moron. You can't apply this to that because this is not an angle, you utter twat.
So he was just doing a conversion when he wasn't expecting an equals.
Converting rise over run is not degrees because you haven't done an arc trigonometric function on it.
Anyway, carry on. Sorry, I interrupted. I was just shocked.
It's not an angle, so you cannot just multiply by pi over 180, which presumably he's going to try and...
Has he finished the equation yet, Glenn?
No, and that's why I don't understand why he was
exactly. What an arrogant prat! He's about to have his arse handed. I assume he's about to have his arse handed to him, as what you pointed out.
So have you finished this? Have you finished this, Fed?
Unfurl within the derivation.
You wish to add to the end?
Is probably so ignorant of.
Do you wish to add something to the end of this?
Driving himself would be beyond.
You're a moron. You're a twat. You're lying. You're lying, moronic twat.
Maybe Rumpus should shut up.
I'm in the middle of talking to Fed here, so can you be quiet? Fed, do you want me to add?
I'd like to hear the end of the.
Let Fed carry on.
You ramble on like a fool.
Fed, would you like to add anything more to this equation?
Yeah, the rest of it.
Yeah, carry on.
He would like.
Fed, carry on. Do you want me to add something? I'm waiting here. Got my keys ready. What else do you want to add to this?
Okay, so add in 100 divided by 500.
100 divided by 500.
Times it by pi over 180.
I've already got that. Can you not see what I've written? Can you not see what I've written down? So why are you asking me to do it again?
So here's the secondary one.
Can you see my screen, you moron?
Yeah. Rise over run.
Right, so why did you ask me to repeat? Why did you ask
me to repeat? He's giving you the second one. He's giving you the second one. Shut up and listen.
Are you happy with what I've written down here? So this is equation 1.
Just do it. Don't ask questions.
Well, hold on. I want to make sure I've written down what exactly he wants me to have. Are you happy with number 1? Is that what you want me to write down?
The second one is rise over run.
No, let's deal with 1. I want to check the number 1 equation I've written down here. I've put a 1 there. Are you happy with what I've written down?
Yeah, the second one is rise over 1.
No, hold on. You've now got it twice, you moron. You've got rise over run here times this, and then you've got it again because you've got times 100 over 500. That's the same thing that is here. You've duplicated it, you moron. So you don't want me to write. It's not what you wanted, is it?
So I said the second one, right? So I don't know why you
we're dealing with the first one, you moron. I've just established that you've duplicated the rise over run. You've got this 100 over 500, which is the same as this bit at the start. I presume you didn't mean that to happen.
No, he was just telling you the figures for the
I
names.
asked him whether he
For
was
God's
happy with
sake,
equation
mate,
number 1.
calm down.
And he hasn't. And he
Do
said
you have an
yes.
inhaler?
And equation number 1 is not correct, obviously, because you've duplicated the rise and the run. Do you want me to edit it? Would you want to give me an edited
Or
version?
he could have just give you the figures for the rise and the run
we're looking at the
words.
equation.
You
We're
know?
looking at the
I
equation.
don't
We're
see
looking at the equation. So,
Equation
Fed,
has
you said you were
equal
happy
sign.
with equation number 1, and now, after what I've just told you, I assume you're no longer happy with equation number 1.
Well, I never told you to times pi 180 times 100 over.
I asked you if you were happy with what I'd written on the screen as equation number 1, and you said you were.
He was just trying to make
happy
sure.
with what? Are you happy with equation 1 or not? Are you happy with equation 1 or not, Fed?
So I never told you. Listen carefully.
Are you happy with equation 1? And if not, tell me how to change it.
He's not happy. He's about to tell you.
Tell me what to change about equation number 1. Tell me what to edit. Tell me what to edit about equation number 1.
I never told you to time.
Tell me what you want me to do with equation number 1. What edits do you want me to make so it reflects?
Can you let him speak, Rumpus? Can you let him speak, mate? Can you just shush? Can you just shush? Please shush. Just let him speak.
He's a wanker, and he's not.
Just let him speak, and he will get to his point.
Can you not tell he's not?
No, I can't tell because you keep jumping in every time he says one word.
Yeah.
I can tell that.
Ridiculous, mate.
He's a dickhead.
Let him speak.
Number 1, we've got equation 1
You're
on
being a
screen.
dickhead here, Rumpus. Let him
equation
talk.
1 on screen. What do you want to do with it, Fed?
Just mute your mic up for 1 minute and let him explain.
Rumpus, shut up. Data, go ahead.
Get away with it.
Go ahead,
Brandon,
Data.
you ask him then. Brandon, you ask him what you want that.
Yeah, Rumpus, he's going to.
I can't get any sense
Rumpus,
out of it.
Rumpus, please.
Brandon, please ask him 500 times. Please ask him
Listen.
500 times.
I want us to agree on the
Give him a
equation.
chance to
He
answer.
won't do it.
Data, do you
He's
want
a
to?
flat earther. He has to insert his emotional spiel. Just let him have it for 1 minute, Rumpus.
Well, I just want him to tell me what to write
Yes,
down.
but
so we can
he
move on.
has to do his emotional thing. He's a flat earther. Just let him. Just give him 1 minute.
But you do not understand the power of Rumpus's emotions. They are too strong.
Tell me what you want me to write down. What edits you want me to
Over
make. to equation
ejaculate.
1.
Just shh. Go ahead, Data.
Yeah, so I didn't tell you to times it by 100 over 5 divided by 500.
You did.
Right? So
you
anyway,
did tell me that. You
no,
did tell me that.
No, so
So do you
essentially I
want
was
me to
trying
remove
do-
that? So can you see on screen? Do you want me to remove the 100
Rumpus,
divided
can
by
we
500?
just hear what he's got to say, mate?
I'm sure you can follow a line of instructions, Rumpus. So
No, wait. What do you
Still
want
got
me to
stuff
do
to
to this
get to,
equation on
guys.
screen?
Just I don't know if everyone forgot, but all right.
I say we just abandon the whole idea.
He's a
Just
moron.
abandon
You
the whole
cannot
idea.
Fred, you
of
cannot
this
pin him
doing
down
it.
ever because he always dodges the specifics. And he
You
likes to
always
have
interrupt
waffles.
him.
No, I'm
Just go on mute yourself just for
No,
one
I
whole
want
minute
him to
because you
tell
keep
me.
jumping in.
I'm asking him to tell me, Gleam, for
And then
Christ's
You have to
sake.
stopping
shut
him
up
from
long
telling
enough for
you.
him to get it out.
I'm not. He won't do it. You ask him. What edits do you want me to make to this equation? Gleam, you
Mute
ask
your
him.
microphone, brother.
No,
mute
you
your
ask him.
microphone.
No,
All right,
you ask
I'll
him.
ask him. I'll ask him.
He
Data,
just won't do it, will he?
Data.
He just won't do it.
Data. What edits do you want him to make to this?
Yeah, so I never told him to times the 100 divided by 500, so you can remove that.
Yes, you did.
And
Ah,
He said remove
and
it.
put equal.
Okay, great.
Let me finish.
Excellent. We're
And
getting
put-
somewhere. I've removed it.
See, 20 minutes just for that.
Are you? I know, but he wouldn't
Yeah.
cooperate, would he? I just asked him.
He
that's
was
what he wanted
trying to
do.
tell you.
No, he wasn't
He said
trying to
that.
do that. I
He
thought he was
said-
trying to be a wanker. So, are you happy with this now, Fed?
He's
and
the
leave-
wanker.
Are you
in all-
happy
in
with
all
number
fairness-
1?
I'm not
in all
happy.
fairness, Rumpus,
Are you happy
I'm
with
not.
equation 1?
Yeah.
It's very
Not an
simple.
equation.
Hold on, let Data
I
answer.
know, I'm getting to that. I'm getting to that, Chike. I'm getting to that. So, are you happy with what we've got for equation 1? Are you happy with that? Yes or no?
That's fine. Go to equation 2.
Right.
rise
What
over
is
run
this
time.
equal to? Hold on. We haven't got to the punchline now. What is this equal to?
To
What?
degree calculation.
So this is equal to degrees, is it?
Yep.
Okay. And what is it? Degrees of what? The angular size. Is that what you're
The
saying?
degree
it is?
of the triangle. It's the
Right.
It's
So it's the
subtended
angular
angle. It's the sub-
size Okay, let me make this a bit smaller and make it.
It's the sum angle degree.
So here we
from
go.
The
Right,
object
so let's
to
make
the
sure
point
we
to the
all
observer,
understand this. So the angular size in degrees. Whoops, angular size in degrees is equal to this thing. Let me just get rid of that. Are you happy with equation number 1?
I think it's 180 over pi, but double check. I might be
Why
being
you need to
stupid.
white knight?
I'm not white knighting.
Oh, you do?
I'm just wasn't happy with it. So
Well, we want to know if Fed's happy with it. That's the key thing we're trying to work out here, because he doesn't like being pinned down.
We might be right.
That-
It might
that
be
was his
180 over pi. Hold on.
equation.
I might have.
What are we trying to achieve here in terms of
We're trying to achieve the showing that Fed is a stupid moron. That's what we're trying to
We have a
achieve.
goal?
What's the conversion we're trying to
No,
achieve?
sorry. Gleam, thank you, buddy. Thanks for coming to that. I wasn't paying attention. It was 180 over pi. That's what I meant.
Right.
Sorry.
And what does that give us, Rumpus, now?
Well, hold on. I don't know.
Thanks for doing that.
This
You
guy's
don't
doing
know.
it.
Fair
It's
enough. No,
entirely
I'll
fair.
take that. I'll take
Well,
that.
I do
Rumpus.
know. I'll
No,
tell you
I'll
something.
take it. I'll
Rushy
take
with
it
him.
Something
all
about it at
day
the
long.
end.
I
Thank you.
was
You
thinking
don't
about
know.
the conversion
Don't
back,
know.
right? Like you can.
So are you happy with equation 1, which is the angular size in degrees is equal to the rise over run, rise divided by run, times 180 over pi? Are you happy with that?
Yeah, and then just do the secondary one. You can do a short version of 57.3. So you can take the same rise over run times of 57.3 and you get it the same degree.
So what am I doing now? Am I doing equation 2 or am I
shit.
doing
He
equation
just
1?
simplified
No, he
180
wants
over
you to
pi.
do the
That's all he
calculation
did.
of pi over 180 over pi.
You
That's
want me
the
to check?
second equation.
I thought we were doing a second equation. You're going back to editing the first equation, are you, Fed?
It's just two.
No,
it's
he
just
says
two,
copy
it's just two
the
quick
first.
versions of the same thing.
Do you not
Well,
understand
and
what's going on, Rumpus?
I can't hear him at the moment.
Rumpus, do you not
Be quiet,
understand
twat. I'm talking to
what
Fed.
the guy's
Be
doing?
quiet,
Are
moron.
you so
Be
dumb?
quiet. Be
You
quiet.
don't understand
No,
this
letting Fed
breakdown.
do his thing
Are
here.
you that?
I'm lost.
Are
No,
you?
you're not. I'm not interested in
Are
what you've
you
got to say, Adam.
unable to
I'm trying to
facilitate
listen to what Fed's
this bit
got
of
to
maths?
say, not you.
Is that
So be
what you're
quiet.
saying?
So,
You're not
Fed, what do you want me to
capable
do now?
to facilitate
Fed,
by
what
So
actually knowing
essentially, here's my
the breakdown.
position, Rumpus.
Shocking.
My position is I'm just
Ignorant.
showing you the same version of what you're doing, but a quicker calculation for it.
Right. So
Right?
what
And
do you want me to do?
and
So
the-
for 2,
and the calculations,
in other
the
words,
calculations
actually,
are
so
based
can
on
I say
straight
this is?
lines and
So
angles.
can I say that's D then? Can I say
Simple
that's
rise
angle
over run.
D?
Rise
Can I
over
say
run
that's
is the
angle,
primitive.
angular size? In other words, this
That's
is
what it is.
D.
Straight
Right.
line.
So D is equal to
Vertical,
angular size in degrees, and that's equal to that.
horizontal.
Okay. Right. Is that happy? D, the angle. I'll put this back after I moved it. Let's just put this back here. Right. So let's put this back where it was.
FED, did you pop in here to ruin my conversation just to give Rumpus tips on how to do the math faster?
Right. Well, we'll get to that in a minute.
It's just this is what it is. That
We'll get to that in a second. Right, so now you've given me a formula for D. We're talking to Fed. We're dealing with Fed. We're dealing with Fed. So Fed. So you've given me a formula for the angle for D. We've given me a formula. Now you're about to give me the formula for the angle for
Do
D.
you
Is that
reckon he's
correct?
got any idea what he's actually doing?
So
I don't
Fed,
think he
are you
does.
now going
I
to
don't
give me
think
an
Rumpus
angle
has
formula for the angle
actually
for
got
E?
an
Is that what
idea.
you're about to do now?
From day one, he's not twigged to
Be
what went
quiet,
off.
be quiet, twat. Be quiet, twat. So Fed, are you
As the
now
guy
giving
read the
me a
calculation,
formula?
we both know
Are you
it,
giving me a
and he's not
formula?
twigged, and
Just
now
on
his
mute,
horse is a
Adam.
bit
I'm
twitching,
trying to
innit?
talk to Fed here,
He's
and Adam.
about to go now. and
So
It's
Fed,
hilarious.
you now giving me a formula for E. Is that what you're trying to do now?
He's so lost.
He loves his own voice. He don't care about what you're doing.
He's like a
Fed,
puppy
are you
with a
going
couple
to
of
give me
bricks
a
tied
formula
to his
for
leg.
E now?
Could you imagine seeing this guy face to face? I'd have done socked him right in his grill.
You might see me in a few weeks' time. We'll have do my little curvature test. And
Yeah, I'm sure you would. You're just a telephone tough guy. I can tell already.
Yeah, that's right. Yeah.
Because you talk to people different over the internet than you would face to face,
When they behave like wankers,
That's
and then someone got
obvious.
Adam calling me a
Nobody
liar, when
talks
in fact
to
he's
each
a
other
liar.
the way you've been doing
When
it.
people start calling me liars, then I start
You're
getting
a liar.
annoyed.
You're a proven
Listen
liar.
to you.
No, I'm not. You're a proven
liar.
You are
Liar of
lying
the
about that, you
10th degree.
wanker. You are
Guaranteed
lying
liar.
about that, you
Shown on the
wanker.
internet.
You are lying
Guaranteed.
about that, you
Hours
wanker.
and hours and
You are
hours.
lying
of
about that,
documented
you
evidence
wanker.
of
You
your
are
lying.
lying.
He's
You are
out
lying
there.
now.
People can
You are
watch
a
it.
liar.
People can
You are a
see it.
liar, and you're lying
Go out
now.
there.
You are an
Just
utterly
listen to
obnoxious,
the Rumpus
lying
lie. He's
wanker.
probably lied a
Anyway,
couple
I'm
of
talking
times.
to Fed
Gentlemen,
here. He's going to give me this
It would
formula.
not surprised
Can
me
we just
there's a
let
number of
Fed
lies slipped
give
in
me
there
this
tonight.
formula for E,
He's
please?
been rubbing them out, cracking one off.
Can we?
Hey,
Can we? Can
hey,
we have
Rumpus, hey,
Fed?
as you talk
Can we
about
have
other
Fed?
people being
Can we have
wankers.
Fed? Can we have Fed give me this formula? Fed, do you want to speak up and give me this formula for E, please?
You're probably he's
Come on,
probably
Fed.
cracking it now.
Come on,
This is
Fed.
what gets him going the most.
Is it Friday night?
Come on,
Fed, are you
Rumpus.
going to give up on me, Fed?
KY, dude. KY,
Come
it's
on,
going to
Fed,
hurt.
you're going to give me
It's
this
going to
formula
hurt
for E.
if you keep going at this rate.
Fed, are you going to give me this formula for E?
It will be sore.
Fed, you're going to give me this formula for E now?
Bullshit, man.
What do you mean formula for E? What are you talking about?
You're giving me two formulas. I presume the second formula you were going to give to me was the one for E, the angle for E, was it not? Am I wrong in that saying that? You were giving me two formulas.
Basically, I'm just showing you that it's rise over run.
Right.
It hasn't registered for you yet. So
right, it
let me know when
has,
it
because
registers.
you're a stupid moron. And as I
Let me
said
know.
to you, okay, moron. 10 minutes ago, I told you that rise over run times 180 over pi, you got it round and around the right eventually, is not an angle. You have to do the arctan function on it. Rise over run is not a radian.
It will work out to be the same answer.
Rampos, it's a close approximation of small angles.
Yeah, it's an approximation, but it's not.
Yeah, but for this angle, he will be quite off.
Yeah. In this particular example, we've got quite a large rise over run, and therefore it's not an approximation that's valid, you moron.
It's pretty close. It's pretty close
No,
depending
it's
on
not.
what you want to do, but it is
But
incorrect.
we've got an angle of 22 degrees, and it's not a valid approximation for that
It's
sort of angle.
pretty close. Look in the chat. Look in the chat. I already
Well, anyway,
did
the
it.
point is it's not
I can
correct.
see the conclusion.
Yeah, but it's not correct. So what he was saying was incorrect.
No, yeah, it is incorrect, but it is
Yeah,
a
so
close
it's incorrect. So now we've established
I'm sorry,
what he said
gentlemen.
was
I'm
incorrect.
sorry, gentlemen.
So we got there
I'm
in
sorry,
the
gentlemen.
end.
It's not my math. I didn't invent it. I was
I'm-
taught it by.
What is BioDuel?
So
What
if you want to do
exactly?
calculations, if you want, hold on. If you
Sure.
want to do calculations without using arctangents, this is what you do.
Yes, but
That's
it's
all.
only valid.
No, you can't.
Well, it's only valid for certain situations. You moron! You don't understand that. This is your problem.
What was
You don't
bio?
understand
Hold on, guys.
geometry. You
What-
don't understand
What was
maths, and you don't
BioDuel's
understand that's not a valid approximation.
BioDuel? Hold on,
my math
Rumpus.
doesn't change,
BioDuel. What
brother.
was
Math
your
doesn't- sorry,
what
again.
was your issue with what he's doing? Why did you?
Oh no, it's a close approximation, but it's not correct. So if you look in the chat, I already did all the calculations for both the angles, and what you see is that the first one's going to be 11.459, give or take, and then using the arctan function, you're not going to come to that calculation, and then it's even broader when you look at the second calculation being 22.918, when the arctan is what do we have here? 21.8.
21.8.
Right. So it's a close approximation where you're in the ballpark, but it's not correct.
Yeah,
but would it be applicable? Would it be applicable for the distances we see, or is that just
Probably not.
We have the example on screen. We were dealing with the example on screen. That was the example we were dealing with. That was what he gave his formula for, and it's not accurate. I mean, that one's about 10. It's going to be 10% out.
I'm not looking to what's accurate on a sphere, though, Rumpus.
Well, it's not the sphere. It's nothing to do with the sphere. It's nothing to do with a sphere.
Right.
It's nothing to do with a sphere. This is a simple geometry screen problem on screen now.
If it's applicable for what we see.
Fed answer would be about 10%
Did you use
wrong.
that math?
But he doesn't understand that.
Rumpus,
He doesn't
Rumpus,
understand radians.
can I interrupt? Sorry, Rumpus. You do know that the small angle approximation is only really accurate at less than 5 degrees.
You can decide what the. I think normally it's regarded as about 10. But anyway, he's the one making this. I'm not
They're both
arguing
approximations, mate.
He is making the
They're
argument.
both
not me.
approximations.
This is not an approximation.
Don't mislead.
What I've done is not an approximation.
The small
What I've
angle
done
approximation.
is not an approximation. I've
Let
given you
somebody
the
talk,
exact
Rumpus.
answer. Sorry?
Let somebody talk, man. Jeez,
Oh,
you're
yeah, but
gonna
I'm
be.
being faced with lots of drivel, and we've got to establish that Fed got it wrong.
What's the small angle approximation formula then?
Rumpus, just give Gleam a minute to address the
Hey,
point.
Rumpus, would you like to
first
test that claim
addressed.
just doing rise over run?
Let's
Would you like to
hear
test
that,
this quickly
yeah?
for me? Do 6
Just
feet
let
over
Gleam
15.
address that,
Do
man.
6 feet for 15. Do 6 over 15,840 feet. And
Yes,
times
but
it by
that's
180
not the
over
example
pi,
we've got on
or times it
screen,
by
is it, Fed?
57.3, and tell me
That's
what you
not
get.
the
And
example
then
we've
do
got
your other
on
calculations
screen.
and tell me what you get.
That's not
Right?
the example we've got on screen.
Hold
we were
on.
dealing with
Hold
the
on.
example on screen. when you have a larger run, when you have a larger run, then the small angle approximation is better. But we didn't have that on screen. We had what we had on screen, and your answer was wrong. So there we go. We all know. Well, some of us know about the small angle approximations.
Let him rebuttal. Let him say
small angle approximations, and I don't think you do know. I don't think you do know.
The answer is the degree, right? So I didn't invent this math. This is an alternate calculation.
You don't know how to use it.
Derived
you
from
don't know how
using a
to
calculator.
use it. So you don't know how to use it. I know.
Rumpus, God dang it! You got to let other people speak.
I think Gleam should have a chance to rebut with regards and help us all, educate us all with regards to the accuracy of what's going off. And I think it was quite pertinent, but it seems to be.
Gleam can't do basic economics.
Yeah, it's at least 1 to 2%. It's 1 to 2%.
What is the small angle approximation error?
Yeah, between 10 to 20 degrees is 1 to 2%.
Yeah, I said it was 2%. 1 to 2%. I said that. I said that 4 minutes ago.
I haven't heard you say anything yet.
Probably just after I made the point.
I said that he was wrong, and he was giving. And this is I've given you the accurate result.
Repeatedly,
He's given you an inaccurate result.
10.
I thought we wanted an accurate result.
10 is the number you said. 10. See, I can say it as many times as you said it.
Sorry, 10. Sorry, I said 10%. Yes, it's 10%. It was 10% error.
Not 2.
Yeah. No. There's
Not
1.5%.
1 to 2.
Well, okay.
Now he doesn't even know what he said.
It was.
So who doesn't know about this, though, Rumpus?
Says.
Remember who doesn't know about this?
I know everything. Well, regardless, anyway.
Yeah.
You've demonstrated you can't do basic economics with your
That's
Paris
the Rumpus
calculation.
admission of a complete and total loss. When Rumpus
I'll put
goes,
a site in the
first rule of the
my
internet,
answer is
I'm
correct.
I
My
know
answer
everything.
is correct.
His admission
Fed
is he's lost.
is not
That's
correct.
A tell. In
Fed
poker, that's
is
your
not
tell,
correct.
isn't it, Rumpus?
And I am correct. It's quite simple.
Go and read the teaching materials.
I know
in the
all
general
about
chat.
small angle approximations, and I can give you the Glean, can you give me the binomial expansion that gives the small angle
Oh my
approximation?
God! Stop this Rumpus! You're spiraling.
Come on, then, Glean.
Spiraling,
You know all
mate.
about
No,
small
I'm
angle
not. I'm not going to do any of your
Come on,
stupid
Glean.
maths.
Have you guys had enough?
About small angle approximations. Give me the small angle approximation for cos
I
theta.
will not. I want to actually explain something from an hour ago when you started spiraling. But you're right at the bottom now.
Let's hear what Gleam has to say, Rumpus. Let him speak.
I don't.
Just sit on your hands for a minute, Rumpus, and let him speak.
Can I share my screen? Because if you remember, I said, I think I can explain. And then I turned it on its side and you lost your shit. It's crazy.
Well,
It's
you were
funny.
talking gibberish.
What? By flipping something 90 degrees, bro? It's,
It was irrelevant.
That is
Brandon,
not gibberish.
you didn't forget about the real Bob Dole, did you?
No, how could I ever forget about you, Bob?
Okay. I lost you when you said
I think this will help Bob.
I just handed over to Rumpus to explain one little point.
Sorry, Bob. I feel a bit guilty. Sorry, Bob.
I think this will help Bob.
If you want to take it back, please do. I don't take over from you.
I think this will help Bob. Can you almost see me Photoshop there? And it's just let's pretend it's a photograph where you got the sky and the land. Yeah. If people can see now, I've added some black lines in there, which are just the perspective lines going halves, following the law of halves of perspective. Okay. Yep. Now from back here, let's say this is human view. From back here, that black line just looks all crushed and compressed into one horizon. But if I zoom right the way in, there's multiple lines opening up, and that's exactly what a camera would do and go in. Yeah. And obviously there's a white line, a white dot there, and that would exceed, you hopefully you all lost that. I can't see it on my screen, but
right.
You can't see that. So the compression, what needs to be taken into consideration is the compression of the land going up.
No, Gleam, all you're talking about is perspective.
Do you have to get involved?
Yeah, I do, because you're just talking about perspective. You seem to have discovered perspective. And you did a demo in the 3D program, was it, a year ago, in which you got everything wrong and the coordinates wrong. And
Oh my God.
and now you seem to have
Why are
discovered
you
perspective
distracting?
again.
Why are you distracted?
Let him
This
finish.
isn't basic perspective.
You're talking about
because
perspective. Why do you
I'm
think you're
not.
speaking about? You sound as though you're
I'm
speaking
not.
about something novel and
Rumpus,
insightful,
Rumpus.
and all you're doing is describing perspective.
we just had you
Let
do
him-
what you consider to be simple math,
Yeah.
and you
messed
were
it all
trying to
up.
do that,
You
right?
messed it all up.
Did you just
Rumpy
claim I
boy.
made a
So
mistake?
just doing simple perspective, then just
You
let
had
us
to
do
go
it.
back and
It
correct
shouldn't
it.
spare you.
Okay, I don't know whether you can see this or whether I have to reshare my screen.
No, we can see the
Can you
green
see
and the
it?
brown thing. Yeah.
No. I need to reshare then. If you can give me, can I
There's a
just
way to
change
select your whole
windows? Yeah,
screen
give me a
instead of just
second.
one program. I think that's what I do.
There's no
Or that's what I
compression.
did. So.
Let me show you something that
those
you'll all be a little bit familiar with.
lines.
Okay.
If I do that and then change it to that. If you see Ranty's photo, yeah, so this is Southport where he's looking over, and it's about here that the Blackpool Tower is.
Yeah.
If you can see my lines there of where I've drawn out,
We can see that, yeah.
Oh, yeah.
yeah, if you can see the compression there, obviously we've got this amount of land here compressed into such a small area here.
Yes, perspective, yes.
Yeah,
You seem to have
that's
discovered
basic.
perspective.
Hang on, I haven't even got to my point yet because of your jibber jabber. Quit your jibber jabber, fool.
What is your point? You've discovered perspective, right? Great.
We gave you a lot of time to do your diagrams, do your math.
right
Now
to explain
shut
it,
up.
Brandon, you were generous with me. I'll accept that.
All right.
Okay, now why aren't you generous with everyone else? Are you scared of something?
No, because I mean you're
So
wasting
shut
my
the
time
fuck
by
up.
pointing out perspective.
No, I'm not, because I haven't even got to the point yet. That is basic perspective that I've just told you about.
Yeah, well done.
Now, I say that there is a limit where this all merges into that one single line for whatever optical limit of your device.
Yeah,
And
things get
therefore,
smaller with distance.
no,
yeah.
listen. Oh, for God's sake, you're flaking. So if we go back to Randy's thing here, this distance where it gets so small that all the land mushes into what's ever on top of it, yeah, is less than a fifth of the total distance. So you have all of this from here to the mountain basically compressed,
It's not compressed.
within. It is compressed. It's
No,
basic
vertically.
perspective, remember?
You're worrying about the horizontal and you're not worrying about the vertical.
No, I'm not. It's basic perspective, Rumpus.
The vertical is what we're interested in, not the horizontal. This is your problem.
No, your problem is you can't keep your mouth
Your problem
closed
is you don't know what
enough.
you're talking about. It's the vertical you're interested, not the horizontal.
Go to sleep.
I do know what I'm on about.
It's the size of the mountain, the tower that's important. They're vertical features.
No, you don't understand what I'm saying, obviously.
I don't think Gleam's gotten to his point yet.
Explained it.
I don't think he's gotten to his
Explained
point
it,
yet.
but only at a bare minimum because I didn't get to the details part because you won't let me.
You would assume, Gleam, that Rumpus is setting the standard.
So far,
that at
Gleam,
no
it seems
point
like you're
should you
basically
respect the
entirely
presentation.
cannibalizing the things I was going to
We'll
go into.
remember that for his. So he can
Yay.
We'll
never
this-
respect the Rumpus presentation ever
The
again.
key point is this picture is all
No,
about
what
the
are you
vertical
talking
size
for
of the
still?
mountain
Again, why do you
and
need
the
to talk
vertical
for?
size
I'm
of the
gonna have
tower.
to
How
mute
about
you,
addressing
Rumpus.
I know. I'm addressing that, but you won't let me. Why? Why, Rumpus?
I'm being
No, why?
Okay.
No, you better
Okay,
fucking be
can I
quiet, you
speak?
dick. No, you can fuck off.
Right, okay.
And let me
you-
talk.
the issue is
Let
the
me
vertical
fucking
size.
talk,
You just
Rumpus.
asked me why I did not.
No,
you just
I
asked me a
fucking
question.
did not. You
No.
shut the
You
fuck
just
up.
said
Go on
why
mute. Go on
why
mute. Just shut the fuck
Fuck
up.
it.
I'm trying to explain it.
Now, don't run away,
Right.
Rumpus. I'll unmute you.
I'm trying to
after a while.
explain the compression of why the background object is so lower than the foreground object. But Rumpus won't allow me to. Okay? Because if you get your orthographic view, this is good. We can see this guy and we've got this angle as we was just all calculating. If these are the same height, that's all good. But there will come a point which cannot be represented, or it can be. I've done it in Excel on Ranty's particular one, but it is literally 2 pixels high, which represents 10 meters. And then it covers the whole spreadsheet, literally right across. but it's impractical to represent any orthographic view in true scale. So you have to squash it up like this so it looks like, yeah, this guy can see this guy. Look, there's no problem there.
Get a bigger zoom.
Can you shut the fuck up?
Always have a bigger zoom.
Yes, I know, but there's always a limit on a zoom. And there's
No.
always distortions which come with a
Always money
telephoto
in the
zoom.
banana stand.
Yep, can I just get to the point, Chike, or do you need to interrupt? Is there anything important?
Already.
Yep. This is using a camera. This applies to cameras as well. What's your point? No point? No point? Yeah, you can get a telescope. This still applies to that.
Yeah.
Yep.
The bigger one.
Yep, this still
I
applies
want
to
you
that.
to show me on your
I'm
your,
trying to, but you're interrupting me. Why are you interrupting me, Chike?
Not here, not
Chike,
here.
I'm trying
I
to
want
do
you
it.
to put an object on
No,
your...
I want you to shut the fuck up so I can actually explain something.
He's trying to explain something. Fuck. Let him explain.
Not explaining anything.
I am explaining something. There will come a point where this person is irresolvable. Therefore, he merges into the floor. And therefore, that floor, if you was to invert this triangle, which you can, Sakatoa, yeah, you can put the apparent rising floor up to his head, and he becomes 1 pixel, let's say, or 1 dot of the eye. Yeah. Everything from there onwards, everything from there onwards is compressed into the zone. If I flick back now to Photoshop.
Oh, we can't see what you're
Say,
saying. Oh, no, now we can. Got it.
Yeah, I think I'm back on Photoshop, yeah? So, if we're looking at this, let me see if I've got Ranty's pictures in.
Yeah, in other words, once you lose the light to an angle, you can never get it back. Like, look, like put a hole in a board.
Hold on.
Put a hole in a board. Go ahead, sorry.
That is a different one. The actual ones are in.
I've been reminded that this isn't actually Ranty's photo. It was taken by someone else.
No, it was, yeah, sorry, it was someone else. But that is the so-called, how I've done this is if I put a grid line in there, each of these grids represents 1 degree. So it's 45 degrees up, 45 degrees down. And this is, if you zoomed a P900 right the way in, you would get approximately about 3 degrees by about 4 or 5 degrees going across. And that is what Ranty's is basically getting. So yes, you are zooming in there. However, the calculation based on head height and based on a 0.2 limit, or sorry, 0.02 limit, then the actual horizon would be completely compressed at 20 miles. Around about 20 miles, and obviously the mountains around about 80 miles. 50 miles. So you have a 30-mile shortfall of 30 miles worth of land compressed into 1 single line. Then on top of this, if you take away the degrees, on top of this, the mountain obviously comes above this line. Now, just as the floor compresses in, your field of view for the mountain would compress in as well. So the mountain would be compressing into the floor. And that explains why foreground objects are higher than background objects, because the background ones are compressed.
The mountain.
Yes, it's compressed.
That's what you say, but we don't see it. Can zoom all day.
No, we don't see curve either.
Telescope will not bring it back. Never.
No. Because of your height.
Why?
You need more height.
Why I need more height?
Because height creates that triangle that I was showing you before.
Well, 6 foot is enough.
Well, 6 foot is enough. No,
Yeah,
I don't think it is,
right,
my brother.
Why not?
Jake, you're making excuses. You're winging. You're chucking shit
Why?
at the wall,
Why?
hoping
I
it
want you to
sticks.
model it. Put the mountain there. Let's see
I've
where
modelled
it is.
it. Remember,
Put
Rumpus
the
told me it's
mountain.
all wrong.
Put
You
the
don't know how to
mountain
model
there.
stuff.
You are a
Put the
moron,
mountain.
Dean. You're an
Demonstrate what you said.
Everyone's a moron who disagrees with
Come
you,
on,
but
put the
you
mountain there. Let's see.
are the
How
moron
can you?
for that.
The angular resolution issue has absolutely nothing to do. We can clearly see the mountain and we can clearly see the tower. Angular resolution issues have absolutely nothing to do with this.
They have, because you can't see the floor. And Chris,
we can see the tower, we can see the
Incorrect.
mountain, and we can see that the mountain is not
Yeah.
higher than the
So
tower,
why-
which it would be on a flat Earth. And if you understood simple geometry, you'd understand that's how it would have to be on a flat Earth.
Yeah, simple geometry. My
Mate,
approximations.
That was
You
a
are
nice.
you have less trigonometric skills than a 13-year-old.
Good stuff.
The things you don't understand are
Gleam.
just extraordinary.
Rumpus, mate, I just corrected the conversion for degrees, brother. I've proved myself here tonight. You're all right with your little diagrams.
I have a simple question.
Can I just respond to that nice presentation just for
Thank you, sir. Thank you, sir.
Yeah, shout out to
that
Gleam
was
for that.
fantastic,
I wasn't paying
guys.
attention to what I was saying, Gleam, so much appreciated. Sorry,
There's
sorry.
a lot more to it.
I just wasn't paying attention. I've been tired. I'm actually kind of burnt out today, so I wasn't paying attention. So shout out to Gleam for that. Much appreciated.
All right, so simple question, and it's going to be very simple. If you're talking about angular resolution, we can increase the angular size of an object by zooming in. So on that basis, that we can all agree on that basic principle, are you saying if we zoom in to where the base of the mountain that we don't see that is being compressed that you claim, if we zoom in, should we see more of that mountain because we're increasing the angular size of that area?
You've got a foreground limit and a blockage from the wave. The wave is above the actual geometric height. We'll all agree on that. Obviously, yeah, there's a wave. You're looking across water, aren't you?
No.
What?
Not in the Ranties picture, no.
Yeah, you are, because Blackpool's blocking the other part of the mountain.
I can give two shits about the left side of the mountain. I'm looking over the ground. I'm looking over Blackpool Tower. I'm looking over that city. And I'm looking
You can't look over it. That's the point. You're below it.
Well, I'm looking over it.
It's blocking you. That's called overlapping, brother.
I can see the peak of the mountain. I can see things behind the city. What I'm saying is, if
you can't see the bottom of the mountain,
if it's being hidden because it's
obscured by the curve of the Earth.
Right.
No, it's
well,
not.
yeah,
it can
exactly.
be. It can be.
Seriously,
it can be.
Your attempt to explain the fact that things are dissipating from the bottom would also equally apply to the top. And the Rayleigh criterion has nothing about vertical, horizontal things at all. There's nothing in the equation for that has anything to do with
I'm not talking the Rayleigh criterion. You're thinking that I'm called Nathan Oakley, mate.
But that doesn't. But that's exactly the rules of you. I just suspect you don't even know what the.
You're just muttering, chucking shit at the wall again.
You don't understand.
Just saying you don't understand over and over, just not working on me.
Well, you're a moron. You don't understand.
It's you that didn't understand what I just demonstrated. What flat earthers say happens.
How stupid you are. The top of the thing would be equally applied to the bottom. The rules that you're trying to foist on us would equally apply to the top of the tower and the top of the mountain as it does to the bottom. But it only obscures the bottom. And that,
where did I say the limit was? Where did I say the limit was? Where did I say the limit was? 20 miles. And where is Blackpool Tower before 20 miles?
If you're talking about things being obscured by distance, then the top, the bottom is obscured by because of the distance. Then the top would equally be obscured by the distance. There is no difference in optically or geometrically between the top and the bottom. You moron!
Once you hit 0.02 degrees,
you just showed it. You just calculated it. You moron!
You'll never get anything past 0.02 degrees. You'll never get it back because it's lost.
Brian. The mountain and the tower are both much bigger than 0.2 degrees. So that has nothing to do with this.
Listen, retard. Not the bottom.
Not the bottom.
Retard.
We can see the whole tower. Well, we can't see the whole tower, actually. But the issues you're raising affect the top and the bottom equally. You could argue that the top,
the one-story gift shop
has got exactly the same angular size as the bottom. Yet only the
If
bottom.
you haven't quite
Can I see the gift shop, Rumpus?
You can always stretch.
Can I see the gift shop at the bottom of the mountain, Rumpus? Yeah? If it's 1 story high, can I see the gift shop at the bottom of the mountain?
If you were to lose the bottom of the mountain because of the angular resolution, shut up, Lauren. You can't. Then you would not be able to see the top. The top would be equally affected by the same.
You'll never understand, Adam.
But
Adam, you'll never understand.
Rumpus, you just calculated it.
You don't understand that the rules
you don't
apply
understand.
to the top as well as the bottom, and the fact that only the bottom disappears should tell you that the rules you're using are wrong.
You just proved that wrong, Rumpus. How idiotic you! You just literally moved that thing up and down, and it changed angle.
Yes, it didn't change what disappeared, though, you moron.
Oh my God!
And what's more, in this case,
because the angle changed. The angular size of the object
doesn't
changed.
change what the angular size
No,
of it.
Rumpus. No, Rumpus. No, I agree.
So
The angular
22
size-
degrees.
The angular
So
size
22
does
degrees
change,
is
but-
not different to 11 degrees.
At that
Just
distance,
give me a second.
at that
I
distance-
agree with you, Rumpus. I
At
agree
that
with
distance, the
Rumpus.
up and down is irrelevant.
Rumpus.
It's changing.
Rumpus.
You're no longer any closer to the bottom of the
Rumpus.
top.
All right, Rumpus. Come
Let me
on.
agree with you just for a second. Just for 1 second. I totally agree. In the orthographic view, it doesn't change. But we're not talking about orthographics, are we? We're talking
The
about when we
orthographic
look.
view tells you what the perspective view would be
We
like.
just,
That's how
I
you
just want to
derive the
make sure we
perspective view.
differentiate when we're
Incorrect.
saying the angle doesn't change about the angle that we're talking about, whether they're talking about the optical angle from a viewing point of view or the angle in the orthographic view.
How
which
would
we've
you
all got
derive the
which
optical
we've all
angle,
got
Adam?
distracted with in all
Adam,
the rumpusing.
how would you
We've started to
calculate-
forget about
how
the
would you
differential
calculate
between the
what
two
you-
angles, and we've maybe conflated the two angles into one as if they're the same thing. That'd be naive, wouldn't it, Rumpus? And people would be utterly stupid to conflate those two angles, wouldn't they?
There's a very specific point that's being missed.
I'll
as
take
soon
that
as
as a
everyone
yes.
comes out-
I'll take that as a yes.
I want to get to the. I want to get to this. Adam,
spiraling, I'd like to add in.
calculate the angular size of an object. Would you use the orthographic view, or would you try and use the perspective view?
I'll answer that if you answer the question that I put to you first. Would it be correct to conflate those two angles?
There is no angle in the perspective view. You derive the angle in the perspective
There is no view.
from-
There is. Sorry. There
You do
is
not-
no angle in the
There
perspective
is no
view.
calculation. The perspective view is something that you calculate
There is
from the
no
orthographic view.
angle in the perspective
You
view.
calculate.
I'll take that, Rumpus. No, I'll
because
take that.
an
I'll
image
take that
because a
all
perspective
day
view
long, mate.
just gives
All
you
day
an
long.
image. You just get
There
pixels.
is no
You just
angle
get
in
pixels.
the perspective view. It's
The
brilliant. Thank
angle,
you.
the orthographic
Thank
view
you.
gives you an angle, which is then transferred into a perspective image. The image does not give you angles between things, unless you then map onto that the fact that you make some assumption, like the Fed was suggesting about small angles and the mapping. And by the way, Gleam also got it wrong when he had 45 degrees. That maps he had squares all being the same size, going up and down the image, and that's not correct.
Given that there is no
All right.
angle in the perspective view, what would be the point in analysing a photograph?
That does not give you the angular size.
Given that there
calculation.
is no angle in the perspective view,
you do
what
not
would be the
calculate
point in what you've done for the past 5 years in
that
analysing a
maps
photograph?
pixels to angles, but you don't you use the
Go on, tell me
orthographic
that the
view.
rumpus
You
is
use
always
the
right.
orthographic view to calculate the
First of all,
angular
of the
size.
internet.
If you want to work out,
Go
if you
on.
want to work out what an observer will see,
Answer what I
you
just
have
said
to
to you,
use
son.
an orthographic
Otherwise,
view.
it's just waffle, isn't
You
it?
have to use an
And
orthographic view
losers
to work out
waffle.
what the angular size an odd person would
Losers waffle.
see. But once you've got an image,
How do you work it
it's
out
what-
if there is
what-
no angular size in the perspective view? How do you work that out if? How do
Let's
you
just
adjust for it?
try listening. In
What's
the
your adjustment
orthographic view,
method,
you
given
can work
that, as
out.
you just
You just
stated,
can't listen,
there
can
is
you? You just
no
cannot understand what I'm
angular
saying. So
in
you're
the
just blotting it
perspective
out.
view.
But I can understand that because you're stupid. You
I know,
use
but
the
you're off,
orthographic
aren't
view to work
By
out the
your own
angular
rhetoric.
size, but you can start off with an image
Build
that
by
you
your
can
own
then work
petard.
out the angular sizes
Okay,
from.
shocking.
But if you want to calculate what someone will see in a situation, like an observer, like in the black hole thing,
Calculate.
you have to use the orthographic view to work out what the
orthographic
angular
view-
size, the angular size of things in that view for an observer. That's what you have to calculate. Then you can use that view. If you've never done any perspective,
So I
math,
have to use a
then
side
you
on
have
side
to
ram.
understand. You would
guys-
use an
We ain't talking about
orthographic
angular
view.
size, dude.
Oh my
Dude,
god, you've
listen
never
to
done
me.
anything like this,
Listen
have
to how
you? You've never
delusional you
calculated.
sound.
You've never
Listen
done
to
an
how
angular size
delusional
calculation,
your
have you?
ramblings are.
You've never done an
But
angular
worrying.
size calculation, have you?
All right, we're gonna move on.
Time.
Let's move on.
That's worrying, Rumpus.
Yeah, it's easy to do angular size. We're not talking about the angular size, doofus.
Let's hear what
That is
Biodual has to
the
say. He
question.
tried to
Yeah.
break in a couple times. Biodual, go ahead, and then we're going to get back to Bob's original point, which I think we
That's
lost somewhere along the way.
Thanks. That's essentially what's happening, is that it's an angular size of the bottom of the mountain, in which we're calling it convergence, or the angular size being too small. So on that premise, if you were to raise your elevation to the same eye level as the peak of the mountain, then that same distance that you're saying is cutting off due to an angular size would occur if your eye level is with the peak. So we shouldn't be able to see the same X amount of elevation of that mountain, but from the top down. But we don't experience that at all because your premise is incorrect. This isn't an angular size argument. This is a Earth curve is obscuring or obstructing what we can see. It's as simple as that. There's no convergence occurring, and there's no evidence for that. All you have to do is flip it, change your eye level to somewhere, and then you would expect to see the same thing. We don't see shit disappearing top down, even with angular size.
May I ask a quick question?
Sure.
That's a good place for me to pick up from, because that's
Can I please ask a quick
this
question?
topic is essentially what I was going to get into. Go ahead and do your thing there. Leo, I think
my question is, if the mountain's base is, let's say, 3 miles long and 50 miles wide, and the mountains are 3 miles long and 100 feet wide, and the top of the mountain's 500 feet high, isn't that whole entire calculation part of the angular size?
Yeah, but if you're on the same mountain range, let's say, even though it's 50 miles away,
it either is or is not.
No, listen, wait there. Can you help? Wait.
The
You could be
question was
both.
simple.
Yes,
Is the
and I'm
entire
answering
width,
it. Not necessarily.
length,
No.
and height of the
No,
mountain
not necessarily.
angular
You
size?
don't. There we go. There's your simple answer. No.
No?
No.
Yeah, it is.
No, it isn't. No, I can explain if you
Whether
will
an
let me.
observer is on the mountain,
If you don't
or
want to
off
let
the
me,
mountain,
though.
the angular size is the entire
No,
mountain.
because the prominence.
Base and
If
all.
you're on the prominence and you treat your prominence not as above it, and you say, "Oh, look at the mountain," based on the foot level of your prominence, then no, you're taking the whole mountain when you shouldn't do. You should take it from your foot level.
No, I'm taking the angular size of the entire object, not where I'm standing down. I'm just saying the base of the mountain, all the way across, the width and the depth and the height is the angular size, period.
But you do that and you'll get miscalculations.
No, I won't. I'll get the exact angular size of the mountain.
You reckon?
All right, Bob, you want to pick up now?
Okay.
Rumpus
just proved
you wrong, but either way.
Okay,
on, Bobs.
so I'll start sharing my screen again. And what BioDual is said is basically, I was going to address that eventually, or that idea of we don't see things disappearing from the top down. There's a reason for that. So, okay, so this is the picture we were looking at, and like I said, this is essentially what was given to me as by the Dr. Bob character, as this is what the flat earthers are arguing, is that the adjustment downward would somehow change things, and that is somehow affecting how much of the building you see. That's a basic overview of what he seemed to be describing to me as the flat earth argument. I disagreed, and I indicated to him that that's not the argument that I understand to be the issue. Okay, so I'll go ahead and move over to this. So this is a similar picture here, but I got some. Oh, I don't want to zoom in that much. Sweet niblets. Well, can you guys see this? It's got the red triangle and the blue lines and stuff.
Yeah.
Yep.
Yeah. Okay. So it's a similar picture. All right. We have a viewer over here to the left, and the lines go out to what would be the top of the building and the bottom of the building. Okay. That's not real. Okay. If the viewer is this far away from the building, this isn't a thing that happens. Okay. The angle would actually be more akin to what I have here, the red triangle. Okay. There would be some sky in there, air, whatever. okay? And there would be some ground, all right? And what would happen if you bring this viewer down? Notice what happens to the ground and the inside of the triangle, okay? What happens here is that essentially, when you get down to the ground, half of the triangle is gone. And now all of this information has to be resolved by your eye with essentially half of the resolution that it had before. Okay? So it has to fit all of this information plus additional information, because the ground all the way to you is now being added to it. And you're closer to the ground, which means all of this stuff right here essentially has to be, your eye is going to attempt to resolve it, but it won't be able to resolve it separately. Okay? Because these angles here, I have another picture. This is a 90-degree angle, and this is what I explained to Bob. Okay? And he seemed to agree with it, which is, with this 90-degree angle, it doesn't matter how long these lines get. This will never ever be anything other than a 90-degree angle, no matter, even if these lines go on into infinity. Okay? But what will happen is that this volume will continue to get bigger and bigger and bigger and bigger on into infinity. Okay? So with our eye, as we look further and further and further and further away, the information that we are attempting to put into the angle becomes larger, the amount of information, but the angle, like I just showed with the 90-degree angle, the angle never changes. Our visual angle, what we can actually see, that's never going to change. It'll always be the same angle. But we're trying to fit more information into it. So as we look out further and further and further out here, we're forcing our eye to attempt to resolve more information in the exact same amount of space. And like I showed here, when we come down in the elevation, we're essentially cutting off with the ground part of our resolution with the ground. And that's also why it doesn't happen with the sky. If we move up, we aren't cutting it off with anything. That's why we don't see things get cut off from the top down. We would, if we stood here with a ceiling exactly above our head, we would start to see stuff get cut off from the top down.
Just like in the hallway.
You can test this. Because if your argument is that it's essentially information overload, you can use a telescope or a camera with zoom, and you can bring those things that your eyes can't see back because you're changing the angular size to make them bigger. But we don't experience that. So you can test this theory, and the theory is null and void because cameras and telescopes
Okay, no, wait, hold on. What I just explained, it's an explanation of how our vision works, how our eye works, okay? What it didn't do, my explanation, was include the other variables that you necessarily have to then add on top of just this basic concept. So what I just explained does happen with your eyes, and that is exactly how it works. And then on top of that, you would need to add things like the atmosphere and what it does to light.
Bob, let's say you're right. Try to put your red rectangle like the observer is looking up at the sky. Put it at ground level, and the observer will look up in the sky.
Like this?
Yes,
and then the tools on here are not necessarily great. I don't know if I can. Here, let me try and make a different triangle. Let's see here, because I'm just in basic paint here, so I got to try and figure out if it's gonna let me do a.
Yeah, that one right there will work, and then draw that out.
Oh,
well, that's sort of. No, not quite.
Different, the other way, from right to left.
From right. You mean with this one?
Yeah, start from where you're. There you go.
Okay. Yeah. Okay. So like that.
No, to the other side. First.
Or is that too much? You mean not a right angle? Or not
Right angle,
yeah.
but looking right, not left.
Let's try this. Nope. Okay. So let's try this.
That's okay. That's okay.
Like this.
Right. Now there's
Right,
no
okay.
problem. Nothing sunk below the earth, and you should still see everything.
No.
Yeah, that's like the ISS looking down at the ground. That's why you don't see curvature.
Observer looking up, just looking up.
No, this
Right,
would be
okay,
like
okay.
the top with looking down. This would be like the
What's
very top of the
preventing-
screen. Yeah, the very top. That's where the observer is in the very top.
They
looking
just lost
straight
their
down.
shit for me doing this.
Why should the observer not see the object now?
Because this is why the Earth is flat. From
Calling
above.
is field of view. Field of
No.
view starts where the object is. You should see everything and plus some sky.
Yeah, like from the very top of the screen, that's where your observer is, looking
No,
straight down.
there is no lens to squish and smoosh and.
Okay, so I want to explain what you're seeing here. What you're describing is this, okay? You're describing essentially an observer laying on the ground with his feet over here, looking up like that. So when you're doing that, you're still not going to see the bottom of the building.
Why?
Because
That
you're
was your
looking over
vision. That was
here.
your
That's
cone of
why.
vision. It was your cone of vision. That's what you see in all of this. From the left leg
Okay,
of the triangle
maybe
to the
maybe this
bottom
red
leg of
triangle
the
is
triangle
tripping
is
you
what
up.
you see.
If the triangle is tripping you up, okay, listen here, watch. I'll do this. I'll draw this triangle like that. Okay, this triangle isn't showing you reality of what you see. This is an estimation to explain a concept. I could place this way over here. This isn't what the blue guy's seeing now that I put it over here. Okay, all I did was put a triangle on here to try and illustrate what you just said, which was looking more upward from this position. But if you actually took the time to measure it out, he wouldn't be seeing the bottom of the building if he's laying here looking like up here. The bottom of his vision would be like right there. He wouldn't
No.
see anything
Why-
down here. He's looking up into the sky.
No, if you have 100 degrees a cone of vision, that's what you have. Don't matter where you look, you see 180 degrees. 150 or 180, depends.
Yeah, but as you gain distance from any object, the object decreases symmetrically in size in all directions, right? So with the ground, your eyes being closer to the ground than most objects, like a skyscraper or something. Then above you, the top of the skyscraper, which is sitting in the sky, right? Your angle to the ground is reduced way more than.
Right. Basically, the bottom of the building has to start sharing the amount of we'll call them pixels that your eye has. It has to start sharing those pixels with the ground as you get closer to the
Right.
ground. Okay? And your
Let's
eye
go-
at some point stops being able to resolve the ground and the bottom part of the building as separate pixels. So it looks like the ground is eating up the building.
Why only the bottom? That doesn't make any sense.
Because there's nothing up
closer
here
to
to
it.
compete with the top of the building. There's no
Yeah,
information
closer
to
to
interpret with the building.
You're closer to the ground. The angle to the ground
Right.
is far closer than the top of the
Let's do
building.
it.
Uh-huh.
Let's do
Air
it at the
doesn't
dot.
compete with the objects around it for resolution in your eye. You can see right
Really,
through air.
do you know how
Let's just-
triangles work? Actually, the top of
Okay,
the building is farther
okay.
away from you.
Let me just say this real quick,
Yes,
okay?
so it will be foreshortened more.
It's not the point.
Hold on, guys.
That
Let me
is
say
the point.
this.
You're saying it's too far away from you, and therefore the bottom
No,
disappears.
I'm not saying it's too
but
far
the top
away.
is
I'm not, I
further
didn't say
away
that at
from you.
all. I did not say it's too far away from you at all. That is not the point at all. The point
Really, you
is
said
that
it's
as
too
you
far
move-
away, so you can't resolve the ground from the bottom. That's what you said.
That's not the top of the building, is it?
Yeah, so the top of the building is farther away, so how come you can resolve
Okay.
the top of the building
So
from
the
the
top
sky.
of the building
That
is
doesn't
farther
make any
away from the
sense.
ground. Is that
You're
correct?
not making
Is
any
that what you're
sense.
saying? Are you
Let
saying
me
that the
try to
top of the
explain
building
it,
is
dude.
farther away from the ground, like I said,
Yeah, let me try to explain it to him
or
so
like I
he's
have here?
that way. Even if I'm wrong, even you guys can correct me. So let me try to explain it better. This is why I like to use the basketball court, but I'll do better than that. I'll still use the court. So you're
please do
standing at
better.
one end. You're standing at one end of the basketball court. You can see all the lines painted clear to the other end of the basketball court. Right? Now, if you reduce your eyes to the tips of your toes, you're not going to see every line on the basketball court. Matter of fact, the pole at the other end that's holding the hoop, you might miss like an inch of it at the very bottom of the ground.
I'll add on to that. I'll add on to that. Okay. If
Yes, you
all you're
would.
considering,
No.
if all you're considering is your position.
This is here's where he's going to argue, though. So hold on.
Okay.
Now, with your eyeball, listen to me. I'm almost done. With your eyeball, about an inch of the bottom of that pole, you won't be able to see. Like if you did.
I want you to show me something.
Let me finish. Just like the lines of the court disappeared as soon as you put the tips of the.
You're claiming that, but do you have any evidence there?
Hold on. Because if you even with the eyes,
Hold
the
on
tips
for
of
what?
your
You're just gonna claim more stuff, and you're not showing anything.
No, you ain't listening. Even with the eyes, I'm agreeing
I
with
listen,
you here.
but you're not demonstrating it.
Agreeing with you here, you're not letting me go. Even with the eyes at the tips of your toes, you can't see the lines, all the lines on the court.
Yeah,
and you're probably
we got that. Show it.
probably missing an inch of the pole. But if you zoomed in, right? If you zoomed in, you would see the very bottom of the pole, right? So you take the math of that basketball court, the distance, and without the zoom, with just your eye, you take that math to get your angle of sight, right? And then as you, even with a zoom, an optic zoom, that math is still applicable because the more you zoom in, it's the same thing's happening. The same thing is still happening.
Oh my God, get on with it. You're not
In the
saying
line,
I want
anything.
to do it to
I want to add on to what he's saying.
At a certain distance, even with the zoom, you will not see the very bottom of the pole.
Yeah, you keep
Yes,
saying
yeah.
that. Show it.
Things happening.
Okay,
Go ahead.
I want to add on to what he's saying too. So the lines, and we could just pretend this is now a basketball court and this is the hoop over here, whatever. Okay, the lines that are on the basketball court, okay, and it looks like it's sticking up out of the floor, but I'm just putting this for distance. Okay, this one over here is further away from you. This one is closer to you. What happens when you bring your eyes down and you can't necessarily see all of the lines anymore? This first line is not physically obstructing the other lines. What is happening is that these lines are competing for the pixels, and I'm calling them pixels even though that's not what they are, but the pixels in your eye that are detecting this area, they're being competed for by all of the lines on the court. Oh, whoops, I got to change back to a box. For all the lines on the court, they're all competing for the same general area of your eye to be resolved. And the ones that are closer to you are going to be resolved separately first before the ones that are further away from you. But these lines are not physically obstructing each other.
Listen, absolutely not. There is no such a thing as competing. They
Okay.
are only competing.
Anybody who
They are only
is thinking
competing.
logically and reasonably understands that what I just explained is absolutely true, and you can do it with a
No,
chessboard.
it actually isn't. You're not making
It
any
absolutely
sense.
is.
No.
Listen, they are
it's
only
not.
competing. They are only competing if they're below the Riley criteria or too big for the cones and the rods in your eye. That's the only time they are competing. Now let's do this experiment. Now let's do this experiment at night.
No, you're just
When
hand waving that,
nothing is
dude.
competing, there is no
you're
light
hand-waving
from anything. Hush now.
No,
There
when
is
you
no
raise,
light from the ground.
when you raise and lower the observer's
Dude,
height,
I was speaking. Please, I let
you get a result, a different result.
Yeah, I do. I can easily. I can easily.
Lowering.
Listen, I can easily. Now, to avoid any competition on your vision, we will use a tower at dark, pitch dark at night, with light at the top and light at the bottom. There is nothing competing about in your view on your vision because there are only two lights. Those are the only two competitions. And give me one reason why I won't see the bottom light.
It'll be cut out by the angle of your sight. As you raise in elevation, you see the light. The closer you get to the ground, the angle of your sight is reduced, and it's cut out by the ground.
I want you to show me this happen.
I just did. I didn't show you.
You said things that never happened.
Okay, hold on a second. The next time you're on a basketball court, put your temple.
That won't happen. I won't be on a basketball court. You need to go there, put a light source on the bottom of the basketball court. Put your camera.
You prove it yourself.
No, you will prove it to yourself. Go to the basketball court.
Already did.
Put a light at the ground level. Go to the other side. Put your camera down and tell me you can't see it.
Well, that just depends.
Are you guys still watching my screen? Guys, are you still watching my screen?
Hold on. Yes, it depends.
Are you still watching my guys?
Hold on. He's ignoring what I'm saying. He's holding the distance, the limitation distance of the basketball court. I'm using the court to give you an idea of what's happening. The further the distance, hold on, let me finish. If you take 1,000 basketball courts and you extend that light out, right, and lay it on the fucking floor of the basketball court, you will not see the light.
Yes,
you
I know,
will
because
not see
Earth is curved. I know.
No, it's not.
I know.
That'll happen on a flat plane, dude. It'll happen on a flat plane because your angle of sight and all the compression is compressing it all. It's being blocked by the ground.
No.
And as you raise an elevation, you see the light.
First, you need to measure 100 basketball courts long to be straight. Then we.
Well, that's just a foundation for your mouth.
No, it's
you
not
can
the
extend it out.
foundation. It's what you're making.
You can extend it out.
Chucky, just stop being lazy and go out to the basketball court and do this for yourself.
Watch his stream. Hey Chucky, watch his stream right now. What he's doing on Minecraft. It's actually a really good demonstration that you probably should check out.
This is pretty simple, guys. This is really really simple. And watch this. This is a flat world made out of straight lines being displayed onto a flat screen. And watch what happens. First of all, I've showed this before. With only a 110 field of view, which is lower than what we have as humans, look what happens when you go up into the air. It looks like it gets curved, even though it's super duper not. It's just a flat world made of cubes. But watch when I go down. Watch these basketball lines here, or the lines on the basketball court. Watch what happens to them on this screen with a limited resolution. Watch what happens. What's this?
Now can you move away?
It's like they're competing for the same pixels.
Fantastic.
It's like they become one thing. What? What?
Wait. We weren't talking about the basketball court, but what's on it, right?
Now that's exactly what we're talking about.
Do
you see this?
Disappear.
Watch. Do you see this?
No, I want to see the building.
They start off separate. Some are further away, some are closer.
Get away from the objects that are on the ground.
And then as you get closer to the ground, your eye level is even still a little bit above the ground. See, look, my eye level's still a little bit above the ground, and it still looks like they're competing for the same pixels and have become the same thing.
Can you move away from the objects that are on the ground?
Yeah, I can move away. I did.
So
I can get closer, and I can move away.
It sounds like the gentleman. It sounds like.
Do you think that moving away is going to help your case, buddy?
Yes, I want to see them disappear.
Getting away doesn't help you.
Go down. Oops,
that doesn't help.
Hold there. Go back. Tell me when they start disappearing bottom up. Go back. No, back. No, not
Yeah.
closer. Further away.
Closer. What's
no,
this?
I don't want closer. I
What's
want
this?
farther away.
Yeah.
You
Far,
want
far
farther away?
They
start to compete with
keep
each
an eye
other,
on the dark
don't
brick. Keep an eye on the dark brick on the last one, Chike, and tell me when it's
Yeah,
still there.
they'll
You
all
see?
converge into one.
You
They'll
see?
all converge into one.
You still see the
I
dark
can
brick on the
still
floor?
see them. I can still see them.
No, on the floor.
You can't
the
see
result
them.
of the
You
bottom.
can't see the ones on the
them.
floor.
You see
I
the
can
floor?
still see
You can't
them.
see the ones on the floor. You
No,
can't.
you got to see
Of
the
course
floor.
I
The game,
can.
the game
I
was
did.
Where's
even,
the bottoms?
I mean, it might have still actually had it over there because of how far I have it.
Yeah, remember the game doesn't have refraction, so you got to put that in there.
No, but you see all the
But this
bottom
is
ones.